resemble exactly the trabecular structure of a bone tissue. And the structure was characterized in terms of physicochemical properties, such as in terms of swelling behavior, because it's an important, it's a key property that usually we assess. It means the ability of this structure to hydrate in the cultural medium. And then we characterize also this structure in terms of mechanical properties, and we were able to reach mechanical properties in terms of compression modulus, which are close to the tissue, bone tissue. Afterwards, we characterized also in terms of biological properties of this structure by using 7F2 osteoblast as the cell model, and which are, as I said, osteoblast cells. And as you can see also from the histomorphology, the structures characterized by the presence of black soldier fly or melanin were able to speed up the process, the bone tissue remodeling process, as you can see from the collagen deposition, the formation of bone tissue inside and around the 3D structure. We also worked in an European project in cooperation with the Sichuan University of Chengdu on hyaluronic acid. The idea in this project was to chemically modify this polymer, and we used two different modifications, two different approaches. From one side, we modified the structure, the polymer backbone of the hyaluronic acid obtained from Streptococcus equi strain with metacrylic anhydride to obtain metacrylated hyaluronic acid. Again, this polymer is photocross-linkable. And from another side, by reaction with maleic anhydride to obtain maleated hyaluronic acid. So I will not go, I'm not going deep into the chemical synthesis, but by exactly tailoring which one is the ratio between the metacrylic anhydride or maleic anhydride with the molar ratio of the hyaluronic acid, we were able to fine-tune the degree of substitution from one minimum to maximum value. And of course, the degree of substitution of significantly alters the mechanical and the physicochemical properties of the polymer. So, in this slide, I just summarized the results in terms of physicochemical properties. As you can see, the reaction successfully was obtained, and exactly the moieties were effectively branched to the polysaccharide chain. And afterwards, we were able to print this structure. As you can see on the right side, we were able to obtain this structure with a trabecular morphology. The structure were well defined, as also defined by the CAD model, and we characterized, in this case, we use this structure for wound healing application. So, as you can see from the slide, we implanted also in cooperation with the Suyang University of Chongqing, and the results were really promising. As you can see, no skin reaction were assessed in presence of our material, and also these morphologically results indicate that both material, MEHA and MAHA, had no severe inflammation response to the implanted skin tissue. But we also used this platform for the delivery of exosomes. Why exosomes? Exosomes obtained from human mesenchymal stem cells. Exosomes because recent evidences show that the exosomes, which are vesicles, biovesicles, are able to improve like cellular processes such as angiogenesis and bone drilling. And so, as you can see, we were in cooperation with the University of Ferrara. In this case, we extracted exosome from human mesenchymal stem cells through ultracentrifugation, and we used as a drug delivery platform our material, our carrier, And as you can see from the slides, from in vitro results and also from in vivo results on the right part of the slides, the results are again promising. I mean, the human mesenchymal, the release, the control release of exosomes, of human mesenchymal stem cells exosomes from our platform was able to enhance the ability of the cells to promote collagen 1A1, collagen 3A1, and also elastin and mRNA expression, while for the UVEC also to speed up the angiogenesis process and to form tubes. So in another project, we used, this one was more focused, this project was more focused on wound healing application again, and we designed a new topic formulation based on synthetic polymer, but this time combined also with collagen and gelatin extracted from Rapana venosa, and this also formulation combined, in this formulation there was also the presence of ethanolic extracts of Cladophora vagabunda and also grape pomace. This hydrogel formulation was fully characterized from a physicochemical, morphological, mechanical point of view, but here is a slide that just summarized the main outcomes of our biological in vitro analysis. And as you can see from the third formulation was able to speed up the wound healing and also the migration of cells. As you can see from the scratch essay, I mean the scratch is almost closed. The material was also characterized in terms of antimicrobial properties, and the results are also good. Indeed, as you can see, the different formulations were had also antimicrobial properties against the most common strains attacking the wound. So Staphylococcus aureus, Escherichia coli, and the Candida albicans. These are the results of another project. I just summarized here in this slide schematically, and as you can see, the idea was to develop some platforms and so some membranes for liver tissue engineering. As you know, liver is the only organ naturally able to regenerate itself. But our idea was to design the structure as a 3D model, in vitro model, then to study also the pharmacokinetics, pharmacodynamics, dynamics of different drugs and how they can be metabolized. So the idea is always also in line with our guidelines, European guidelines, also to reduce the number of animals for the experimentation. So we obtained this structure by using collagen. This collagen was obtained from the valorization of fish discards, in particular from jellyfish. And this collagen was combined with chitosan. Chitosan again was obtained from the valorization of fish discards, and so from shrimps. And we used the chitosan also was chemically modified again to induce specific physicochemical properties. And as you can see from the picture on the right, we were able to reproduce the exact liver tissue milieu, and in terms of mechanical behavior, in terms of physicochemical properties, and also in terms of morphological features. As you can see, exactly the cells were characterized by the typical feature like that of the liver parenchyma. This one, I think, is the last, or almost going to the conclusions. these one are the results, the new results achieved in an important European project in which our institute was a partner, and this project had the ambitious, I think is almost finished a few months ago. This project had the ambitious goal to reproduce human meniscus. So meniscus is a tissue present in our joint, in our knee, and for this we used a collagen matrix, collagen again obtained from the valorization of fish discard, and in this case, as you can see through the 3D printing approach, we were able to obtain this well-designed structure, like cartilaginous structure, like the hair, like the nose, like the meniscus is the first one. And the results are promising. At the last stage, we also implanted in the rabbit model, and the results are good. This one is the last project, also in cooperation with University of Rabat, so Professor Walid Abousti and Professor Khalid Azzouti. Like we can say, it's one of the first. Our idea was to design new materials as a platform for the delivery of neuroprotective molecules, natural molecules, and for the treatment of neurodegenerative diseases such as Parkinson, Alzheimer. So in this project we designed. This one is a recently review that we published, and so it sets the first, because in the future we will have some good new results. And so we designed a ionic acid derivative hydrogel for the delivery of bioactive molecules such as rosmarinic or mint, and the approach is new because the idea is also to use this one as in the intranasal as an intranasal strategy. And so the idea is in this way to bypass what it is the BBB, so the blood-brain barrier. And so these one are just ongoing, but I was happy to also share the idea of this project. So in conclusion, the take-home message that today I hope that I was able to give you is the potential. I highlighted exactly the potential of using nature-derived biomaterials and bioactive compounds for the biomedical field. Just as an example is tissue engineering or drug delivery, and the potential also to use new technologies such as the bioprinting to process those biomaterials. Essentially, I'm an engineer, and so I always like to remember that there exists a really important relationship between structure, property, and function of the materials. What is, I mean, it's a triangular relationship. I mean that the materials, the final, taking into consideration which one is the final application of our material, it's always important to consider that the materials can be also, the properties of the materials depend not only on the chemical structure, on the chemical, the bulk properties of the material, but also they are exactly the consequence of the technology that you use to process those materials. So also the possibility to, in this way, it's really important to consider that it's really important to tune, it's possible to tune, to control the physicochemical, the mechanical, and also the biological response of these biomaterials for taking into consideration the specific final application. Thank you for your attention, and yeah, thanks a lot for this opportunity.
Thank you, Professor Ugo Damora, for your nice presentation and innovative approaches that you are making with your teamwork. So I always believe that interdisciplinary connection should be involved in the research area. You are engineer, and you certainly are working with physicians, chemists, biologists, so that's nice, making interdisciplinary approaches for research area. Thank you, Professor Daugo. The session question is open. Is there any question for Professor Ugo? No question? Walid. Nico is there.
Thank you. Thank you very much, Hugo, for your nice presentation. Indeed, from waste to life, we can use biomaterials either from plants or either fauna or flora, either as a drug carriers or other drugs in themselves. But whenever we are talking on having this discussion about drug carriers, so in some parts of your presentation, you are talking about drug carriers that using hyaluronic acid. And the hyaluronic acid by itself, it's an anti-inflammatory. So I'm thinking of diseases that where we are looking actually to induce immunosuppression instead to look for the anti-inflammatory effect. So there is something like we can use instead of the hyaluronic acid, but it gives us the same efficacy in terms of drug delivery, drug biodisponibility, and everything. Thank you.
Yeah, of course. First of all, I just want to point out that, for example, the anti-inflammatory properties of hyaluronic acid strongly depend also on the molecular weight of the material that you use. So if you use small molecular weight hyaluronic acid, of course it has it may have also pro-inflammatory properties, so can induce also inflammation, which is also an important step of the repair, of the tissue repair. So it strongly depends on the hyaluronic acid. But of course, we are working with a plethora of materials that can be used also for drug delivery, and there are a lot of different strategies that we can use, because we can use different stimuli to induce the release of molecules, or maybe we can, like for example temperature, like for example pH, like for example different stimulus. For example, I didn't show the results, but we have a cooperation with Medical University of Charleston, and we are working on design of an innovative drug delivery system of different drugs, with different drugs for the treatment of triple-negative breast cancer cells, cancer. And in this case, we used a synthetic polymer combined also with the chitosan. So the synthetic polymer, because for example, it gave it's temperature responsive, so it means that at a body temperature like 37 degrees, the material can solidify, so can make a gel, so it can be injected when it's liquid, but inside the body the material can gelify, and it's really important also to control then the release of the molecule. And this one was also blended with the chitosan, but why chitosan, for example? Because you need to know exactly what I want to say in the last slide. You need to know the physiology of the tissue and the mechanism of the disease, then to design your materials, and then you can change the properties of your materials to adapt to the specific application. In this case, we used chitosan. Why? Because usually the cancer extracellular environment is mostly acidic. So at pH 3.5, the chitosan is below is pKa, can be solubilized, can dissolve, and in this way you can control the release again of your molecules inside the tumor environment. So yes, we can work with different materials, take into consideration what we want to do, and also the process that we want to, like the phase, the stage, or the process that we want to control in some way.
Thank you, Professor Ugo, for your comments. Is there any other question for Professor Ugo? Okay, I have one or two questions about your materials, especially those from bacteria or insects. Did you make some cytotoxicity assay?
Yes, we did. In the case of the black soldier fly, so the melanin extracted from black soldier fly, after the valorization of this material, we did the cytotoxicity, so test, and we characterized this subarmicroparticle suspension, and we we found the exact dose that we can use then in our bioink, considering that, of course, the material in some way also entraps these biomolecules, so also protects these biomolecules. And this one is the advantage also of using the like polymer drug delivery systems, because in this way you can first of all protect your agent from the external attack, and again you can also control the release. So in this way always be in the, like say, the window of the exact dose that you can use in order to not be so toxic. So this way. So this one is the result that we achieved also with the carrier for the cancer treatment. We were able, with only one spot, to, and the amount also was even higher, we were able to destroy the cancer cell, so the cancer, and at the same time without any toxic effect on the mice. So, yeah.
Thank you, Professor Ugo Daniel. Anyway, your work is very innovative, and we are making good work with the natural compound. Thank you, Professor Ugo, again. Please thank him again. Thank you.
Thank you.
So let's move to the next presentation. So welcome with us Professor Ong Wei from School of Engineering, Thanway University. His presentation is entitled Developing Sustainable Medical Waste Solution Toward Environmental Sustainability. Professor Ong, the floor is yours, please. Professor Berger is here. Please join the floor. Did you go? The presentation is not yet given to the... Okay, thank you, Walid. Waiting for the presentation, Professor Weha will present our speaker. Please.
Thank you very much. Professor Ong is firstly a chartered engineer. His research interests are energy, fuel waste management, and human energy for sustainable, environmental sustainable and biocircular economy. Interestingly, is listed as highly cited research in the field of engineering by Cleveland Analytics between 2019 and 2022. and currently is also named as Australia's top early career research in sustainable energy in 2021. Is currently associate editor in the Alexandra Engineering Journal, Carbon Research and April Journal, and is also adjunct professor in Sydney University. Welcome, Professor Anke.
Okay, yeah. Thank you, Professor Hakim, for the kind introductions. So, yeah, I'm from the Malaysia, Sunway University. So I'm an engineer. So my research is about to turn all the waste valorizations to value-added products. For example, like biofuel, bioenergy, bioproduct, biofertilizer, or even the bioabsorbent. So the topic of my presentation today is sustainable waste solutions towards the environmental sustainability. So I'm still waiting for my slide. Yeah, a minute. So most of my work is regarding to turn the waste through the sustainable way. For example, from the biomass waste, I turn into some biofuel, bioenergy, biofertilizer through the thermochemical conversions technology or biological technology. For example, we can turn this agricultural biomass waste into the biofuel or bio-oil, even the syngas. Through the pyrolysis process, the gasification process, which we aim to go through the treatment to treat just waste at the same time, it can convert into some value-added product like the biofuel. So it can kill two birds at the same time through this innovative technology. We already have this technology, just how we're going to integrate this all technology through the engineering way or engineering approach by the sustainable energy. So, yep. So this is the main idea of my talk today. So I still waiting for my slide. Yep. Yeah, as I mentioned. So today the topic is I want to develop the sustainable waste solution because no matter whether we like it or not, so they are the waste productions all the while. So how are we going to utilize these sustainable solutions to treat the waste? So from the engineering approach, so there are two main solutions. One is through the energy sustainability or the energy efficiency. This is one of the more effective way in order for us to reduce the overall carbon emission as well as to reduce the energy consumption. Why I say so? For example, I take an example like the lighting system here. And maybe 50 years ago, we are using incandescent light bulb. So incandescent light bulb, we tend to turn the energy into the heat rather than the light intensity. But nowadays, we are using the fluorescent light bulb. The fluorescent light bulb can be increase the light intensity while the energy consumption or energy input can be reduced significantly. So this is the energy efficiency method. So we still can maintain our lifestyle. We can reduce the carbon emission. Similarly, if we can improve the efficiency for the power plant by maybe 5%, that is what? 5% of the energy can be reduced. At the same time, the 5% of the carbon emission can be reduced as well. So this is one of the engineering approach in order for us to fight or to combat the carbon emissions. So for the second method, we are focusing on the renewable and also the sustainable energy, which we have plenty of the solar generators, particularly in Morocco as well. Then we have the biomass energy, the wind energy, as well as the hydro energy. So the topic today, I want to focus on the biomass-based energy. how are we going to convert those biomass waste into some useful energy? Why? What is the biomass energy? Why biomass energy? So the biomass energy already become one of the sustainable solutions for the oil shortage, the global warming, as well as the air pollution. So the biomass energy basically is derived from the organic material, which is totally unharmful for our life if we compare to the fossil fuel. So biomass energy already become one of the very significant solutions for the oil shortage. So it's already become one of the sustainable energy together with the solar energy. So the biomass energy is work towards to the net zero emissions. Why I say so? Because the biomass energy basically is come from the agricultural biomass waste or our plantations. So our plantations itself can be absorbed the CO2. With this, the carbon emission can be reduced significantly. At the same time, the biomass energy can be utilized domestic sources of domestic product, like for example, in Southeast Asia, or particularly in Malaysia or Indonesia, we have abundance of the palm oil or even the palm oil waste. We can convert those waste into some useful product or the biomass energy. In the Europeans, they have the surplus of the rapeseeds. So in European, they try to turn the rapeseeds into the biofuel and bioenergy. While in the South America, they are converting the sugarcane into the bioethanol. At the same time, like the US, they have using the sunflower seeds or even the rapeseeds to produce the biofuel and bioenergy. So the biofuel and bioenergy, they produce relatively less emissions compared to the fossil fuel. Yep. So biofuel also can contribute toward the biocircular economy. For example, as I mentioned before, the biofuel is part of the economy that use the renewable sources. It's totally renewable sources that are available locally. And also it can, from the plant, animal waste or microbe to produce what? To produce food, animal feed, or bio-based product, or even the bioenergy through the innovation and effective technology. So the biomass energy can be contributed towards the biocircular economy. At the same time, for example, the bioethanol derived from the biomass can replace the gasoline for the transportation sector. At the same time, the biomass industry such as the oil production, biofuel production, or bioplastic manufacturing from the waste management, it can create economic opportunities in the rural area and also the local community where the raw material for the biomass are sourced. Because if we are using the biomass energy, we no need to import any raw material. We can use whatever raw material or whatever waste available locally. We can utilize that sources. With this, we can turn these sources into some useful product. I mean, it can increase the income per capita for the rural area or for the farmer in the rural area. Yeah, that's right. So, what is circular economy? Because previously, we are experiencing the linear economy, which is the single line linear economy, which resources the natural product. Then from the product, then we manufacturing the product, then we consume the product, then at the end of the life of the product, then we just dispose. Then this one becomes this is the linear economy. While for the circular economy, it's the concept to reuse or repurpose this product, not only from the single process or of the process. Since the raw material that are created or sources, the waste material will create some byproduct or some waste product. From that waste product, we can recycle that waste product. And during when we want to source the raw material, at the same time, during the production process, so some raw material we produce as well, of some waste material that we produce. That waste material, we also can repurpose or recycle it into the some value-added product. So with this, we can form the circular economy. This circular economy, we can utilizing the sustainable energy for the overall process. So from the design, from the product or distribution, even the end of life of the product, then we can recycle and reuse. So this one is the circular economy, or we call the biocircular economy. We repurpose to eliminate the waste material, or even to eliminate the toxic chemicals. So this is the strategies that work towards the circular economy. I think 10 or 20 years ago, we heard about the 3R, which we all reuse, rethink, and also the reduce. This one, the strategy is educate the end user to smart use or productions of the certain materials. Then moving toward, we can reuse or refurbish or remanufacturing or even repurpose of some of the materials or from the waste material. Then recently, we have the strategy to recycle or to recover back the waste material. I give you the example. You see, currently we have a lot of the e-waste from what? Your laptop, used laptop, your handphone, granite. So, all these e-waste will create a very harmful negative environmental impact. Then we can reuse or recycle or re-extract. For example, the e-waste. We have using the very harmful material like the rare earth, like the gold or platinum. We can extract those useful component or compound from this e-waste. Then we can reuse it into the process. So this one is the circular economy that we can have. So I give you another example. So previously, the plastic waste is one of the very significant global problem, which the plastic waste only 5% is go to the recycling. So only 12% go to the incandescent energy generation, while 79% are sent to the landfill. It's totally wasted. So with this, it will create a very huge environmental and also the health impact from these plastic waste. So for the engineering approach or engineering solution, there are two solutions. First, using the thermochemical conversions, which we can convert those plastic waste into the biofuel or bioenergy. The second solution is we can use the bioplastic or biodegradable plastic or compostable plastic in order to minimize the plastic waste problems. So they are for the thermochemical conversion plastic. So we have the pyrolysis and also the gasification process, which the gasification process is focused on the syngas, which the syngas will be produced. While for the pyrolysis process, we will obtain the oil to be further processed into the biodiesel or even the bioethanol. So there are the pro and con for the thermochemical process. For example, the thermochemical process can handle all types of the biomass waste, including the mixed or contaminated plastic. But the drawback is what? It needs a very high initial investment cost. So, but there are few success stories. For example, the black nuts in USA, they are successfully convert the plastic waste through the advanced pyrolysis into the fuel, gas, and also the new plastic product. At the same time, the plastic energy, they also have the commercial plan to transform the plastic waste into the recycled oil. Even in Malaysia, we have the company like the Eco Power. They are converting the waste tire into the carbon black and fuel and even the biogas. So this is some of the success story that we are able to convert those biomass waste into some useful product and can create the economical benefits. So this is the latest technology that we are able to convert the waste to the hydrogen energy through the thermochemical conversion process, the biochemical process, as well as the electrochemical process. So as I already discussed, the thermochemical process, which we can use the gasification process to produce the hydrogens, while the biochemical process, which we can use the fermentation or that fermentation process to produce the biohydrogen. So lastly, the electrochemical process, we can use electrolysis to separate water, H2O, into the hydrogens. So that is the innovative process that we already have. So how are we going to utilize or integrate this process so that we can commercialize it as soon as possible? So this is some part of my study, which we convert the biomass waste toward the green technology applications. In this study, we are utilizing the microalgae as one of the source of material convert into the reducing sugar as well as the biochar. So besides the liquid product, we also able to convert into the solid product in order to reduce the greenhouse gas emission as well as to reduce the realization of the crude oil. So this is one of the study. We convert those biomass waste, including the microalgae, the jatoba oil, or even the spent coffee ground into the biochar. So the biochar can be possible to be used as the solid fuel or biofertilizer or even the bioabsorbents. Then, as I mentioned, we are using the microalgae as our raw material. So this is a newly developed automated photobioreactor with smart monitoring system. So we cultivate the microalgae with some control parameter like the CO2, flow rate, the light intensity, pH meter, and also the nutrient concentration. So this is our control parameter. Then our output parameter can be the lipid. So this is totally fully automated as well as with the smart monitoring system that developed in our lab. So this is the example of our control system harness with the adjustable parameter and also the continuous monitoring systems. So this is some of the microalgae that already cultivated in our lab. So we are using two types of the microalgae, which is the Cholera Vologus ESP31 and FSPE. So these two types of the microalgae, one is the carbohydrate rich, which they have around 49% of the carbohydrate content, while another species is the genetic modified species, which the protein can up to 65%. So the main purpose for the cultivation of these microalgae is one is for the pharmaceutical applications. Then after that, after the extraction of the bioactive compound, the biomass waste is one type of waste. So we go through the dry torrefaction process, which is one of the thermochemical process with the relatively low temperature to convert it into the some value-added product. So what we found here is both jatoba in that study, we're using two types of the biomass. One is the jatoba, another one is the microalgae biomass waste. It can be successfully to convert into the biochar. So we found that through the dry torrefaction process, the HHV, which is the energy content, able to improve up to 45%, and also the energy yield is around 80% by using the microalgae ESP31, which is the microalgae rich in the carbohydrate content, while the torrefaction process have less impact for the microalgae rich in protein and also the biomass, the gentle biomass, due to they have the different chemical composition and structures. So that's we also invent another method, which is the wet torrefaction process, using the wet microalgae. Because for the dry torrefactions, we need to go through the drying process. So the drying process normally is very costly. So we invented the wet torrefaction process, which we can utilizing the wet biomass directly into the process to reduce the drying cost. So in this process, we are using the microwave to enhance the overall process. So there are two types of products that we produce. One is the solid biochar product, another one is the liquid product. So the liquid product, we found that they have the reducing sugar. Then we further process to produce the bioethanol. So this is some of the summary. Similarly, we using two types of the microalgae, which one type is the microalgae with rich in the carbohydrate content, and also another one is rich in the protein content. We found that the overall biochar yield get up to 76%, and also we found some porosity structures after the wet torrefaction process, which is suitable to be used as the bioabsorbent. So after that, we further the absorbent study. So this is another study that we are utilizing the biomass to produce the biohydrogen through the torrefaction process as well as the that fermentation process in order for us to produce the biogas. In this time, we are using the palm oil mere effluent because Malaysia is a palm oil production country. So we have abundance of the waste, the palm oil waste effluents. So we utilizing this palm oil waste effluents to convert into the biogas. Then our another study is we also, because previously we only produced the bioethanol or even the biodiesel. Then we further upgrade the liquid product into the sustainable aviation fuel, which aim to have the almost similar property with the jet airborne fuel. In next study, we identify what is the suitable feedstock or suitable catalyst. So we develop the catalyst, and also we finding what is the suitable sources for the biojet fuel. So from that study, we are using two methods, which is the hydropressing method, which we directly convert using the single process, one single process. One is the deoxygenation, another one is hydrothermal deoxygenation process. Then one with the pressurized process, another one without the pressure. So our aim is produce the biojet fuel or the sustainable aviation fuel that fulfill the ASTM standard. So with this, we have a lot of the innovations process to convert this waste into some useful product. Not only we can produce the useful product, but it can turn into some economical benefit. So are you all ready for this green process to turn this waste or to convert this waste into some value-added product? So with this, I end my talk today. So thank you for your attention.
Thank you very much, Professor Ong, for your excellent presentation. Now, the open section, if you have any question to Prof. Ong.
Yep, I can.
So, thank you very much, Professor Wang, for this case. It's always in continuation with the engineers now.
Yeah.
And how we can use waste. My question is just going to be concerning the microalgae. So for me, it's good to recycle microalgae, but in somehow, I don't know, in my mind, it always come with a drawback. First, how you can compensate for scaling. Like when you are using bioreactors in the lab, we use bioreactors for 1 liter or 2 liters. But we are talking about industrial to find the mathematical function to regulate everything. That's one part. And the second part, sometimes it's the cost to recycle microalgae, because I think like as a first substrate or biomaterials in the first line, like it's the basis to recycle it and to make the most benefits for it. It's so complicated how you can do that. Thank you very much.
Okay, thank you for your questions. Yes, correct. Because in the lab skill, when we cultivate the microalgae in the photobioreactor, it's relatively easy compared to the industry process, which is the open pond process, when we want to cultivate maybe up to the a million ton or 1 ton or 2 ton. So that might be facing the difficulty of the contamination. That is what we mean, I understand. Because for us, we work together with the Taiwan. They have the up to 1,000 tons of the open ponds. So we obtain the biomass, microalgae biomass from them. They already proven. They are possible to have the industry process for the microalgae. The main thing is, first thing, how you going to get the sustainable CO2? So they build the plant near to the industry park. So in the industry park, they have a lot of the CO2 we produce. So they connect the gas piping from the industry, then they go to their open pond directly. Yep. At the same time, they also facing the contamination. So sometimes it's very easy to get the contamination. So in our study, we want to find the stress conditions. So what is the suitable conditions for the microalgae to culture that suitable to the local climate? So that is the thing that we want to overcome. So how to improve the genetic of the microalgae so that we can survive even with the deter contamination. So that is the main challenge if we want to upskill the microalgae from the photobioreactors into the industry skill. Yeah, that is the challenge that we need to overcome. So design microalgae that have the strong stress condition. Yeah, that is the thing. Yeah. Hope I answer your questions. Thank you.
Any other question? Any other question? So the next, thank you very much, Professor Ang, for your presentation, for accepting our invitation to be here in Morocco, and welcome for the next invitation.
Okay.
Okay, thank you very much.
Yeah.
So
I move to the third presentation.
yes.
Yes. So the third presentation is the role of genomics laboratories in academic research, national sovereignty, and precision medicine. This presentation will be done with Professor Zine Rashid, head scientist, lead bioscience scholar lab, Mohammed VI Polytechnic University, Bangalore. So, Professor Zine, the floor is yours, please. The presentation, please. It's okay now.
Okay. Assalamu alaikum, everyone. Thank you for having me. I'm Zina Rashid. I'm the lead of the Biosciences platform at the UM6 Labs. And I'm here today to talk about the importance of genomic core laboratories for advancing research, empowering national sovereignty, and enabling precision medicine with a special focus on their importance in Africa. So before coming to this Congress, I made a small exercise and asked ChatGPT what is the percentage of research and genomic data coming from Africa up until 2024. And the answer was nothing short than mind-blowing and disappointing. The answer is less than 2% of global genomic data originates from African individuals. And this is because of limited infrastructure, inadequate funding, and the shortage of skilled personnel. We yield only about 2% of the global genomic research. However, the continent is home to more than 18% of the global population. And to me, and I think to all of us, this raises a red flag and means that we are severely underrepresented. I also checked the landscape of genomic initiatives in the world, because we are in a world of population genomics and precision medicine, and we need data to enable that throughout the world. And again, the numbers are very similar. And what we find as initiatives originating from Africa is around 5% of the world's total initiatives. So as I said, in an era of genomic-driven health systems and omics-centered research, we do need infrastructure in Africa. And by infrastructure, I mean advanced infrastructure, but we also need more trainings to young researchers to have the very highly trained personnel and researchers, especially young researchers, that can produce high-quality data. So this lack of data and lack of representability has a trade-off. And the consequences are, there are actually many consequences, but among the consequences are a lack of visibility, and by visibility I mean visibility in databases, visibility in research, publications, and the number of citations for the African researchers, but there is also an increasing disparity. And by disparity, I mean disparity in access to technologies like precision medicine and pharmacogenomics and adapted solutions for ethnicities existing in Africa. And let me here give you an example. If we check the top causes of mortality in Africa, we see that we die from mainly communicable diseases, maternal neonatal diseases, and nutritional diseases, and it has been the same 30 years ago. If we look at the top causes of mortality in high-income countries, we find that it's non-communicable diseases, mainly neoplasms and cardiovascular diseases. So it's not the same scope, it's not the same interests. We have to keep in mind that we have to produce our own solutions if we have to solve our problems. Now, genomics core facilities, especially if they are placed in the continent, can help tackle health problems that disproportionately affect Africa, such as neglected tropical diseases, infectious diseases. And research focused on African populations can also lead to the identification of biomarkers, for instance, for specific diseases that affect our ethnicities. You know that the risk scores for finding a specific disease are not the same for patients of African descendants as compared to people from European descendants. And the same is true for challenges in agriculture. And we have our own problems in agriculture in Africa, like the drought and high salinity, etc. So we have to find our own solutions. So the unique challenges of the continent do need adapted solutions, such as adapted equipment installations in specialized research centers and infrastructures, proximity hubs for preparedness, and we cannot have a better example than the COVID-19 and what happened in countries that were not prepared with their own infrastructures, and the development of comprehensive training programs for capacity building, then interactive workshops on relevant African challenges for continued learning, especially for young researchers. Today, researchers from Africa are often obliged to send their samples abroad. And this is not a choice. Sometimes we are faced with the obligation because we think about the budget, we think about the cost, and sometimes we don't even have access to the right technology to do so. Another important problem is the data use and metadata use. And here I will take the example of the patient data use. The concern does not stem only from sharing data, non-anonymous data of the patients, but also, even if the data is aggregated and de-anonymized, there are also concerns related to the nature of the forms themselves. The patients need to know what they are signing up for. They need to understand the forms and not sign or fill ambiguous forms. There is a problem of permitting access by for-profit entities of those data and metadata, and there is also a need for transparency on how these data are used later. Genomic facilities do have a cost, and a very high cost to that. But there is an important trade-off, many trade-offs. Scientific sovereignty, for instance. We need to reduce dependency on high-income countries, and especially in the times of crisis. We need to have our own specialized laboratories ready to operate depending on the need in that specific country, and I will give some examples later on. We need also to allow the ownership of locally generated data and metadata and reduce the risk of biospherices. For the capacity building of your young researchers and scientists in Africa, this is also a very important tool because they need the hands-on trainings, let alone the importance of the economic growth potential of this market, reducing the currency hemorrhage through the local infrastructure, because we will keep our samples enhanced, we will keep also the money that needs to be paid for performing the analysis. There is a strategic value also for promoting health equity and driving national genome projects. And I think that we all know the importance of the national genome projects. And then finally, also answering to various SDG goals. Now, we can ask the question, what is a genomic laboratory? But I prefer, what is a good genomic laboratory? A good genomic laboratory is a well-equipped, professionally managed facility that will deliver standardized, reproducible, and high-quality scientific analysis and services. It should be a pillar of research to the community of the same university, but also to other countries in the continent that do not have the potential to create their own co-facilities. The types of genomic laboratories are either, generally we find either research-focused laboratories or clinical grade. Sometimes we find also hybrid modes. Now, there is a specificity about genomic laboratories, is that we cannot install just a few sequencers and talk about a laboratory. I also like this analogy between sequencers and an arsenal of weapons. We do need multiple kinds of sequencers depending on the type of analysis that needs to be performed. These are examples of sequencers that we do have currently at the UM6P Collab, and sometimes in more than one copy. These are real life examples of the genomic platform. The NovaSeq X Plus, we also have this equipment, and we did purchase this equipment to be able to answer to the questions and needs of the whole university, scientists from other universities in Morocco, and even other collaborators in Africa. And then we also have a genotyping platform, and again, we did invest in the highest technology in more than one copy so that we can answer to the needs of more than just our university. Same thing for the microscopy platform. Again, I talked about the mode. It can be either a clinical grade or a research grade laboratory. But what is important is to be able to answer both questions at the same time and answer to the needs of the patients, but also the needs of the researchers. These are examples. For instance, we can do multiple types of analysis for soil, bacterial, fungal identification, identifying different kinds of species and microbial diversity, but we also do perform some types of analysis that were not possible in Morocco before for the Moroccan patients. And here I cite whole exome sequencing and whole genome sequencing. And up to now, there has been a very high number of samples sent usually to France to receive the results, while we can do the same thing in-house. These are real-life examples. I did not come today to present these scientific results, but rather to preach for the importance of having various and a high number of genomic core laboratories throughout the continent. But this shows just the quality of the data that we could produce from different kinds of samples. I cite well, the first is from whole exome sequencing, and we do produce high quality data with the needed coverage depth and coverage uniformity. We did also perform soil mutable coding, and you can see the quality there, and same thing for human whole genome sequencing. And all this was performed with different kinds of sequencers, with the NextSeq 2000, the MySeq, and the NovaSeq X Plus. We also have access, as you know, we need supercomputing for this kind of data, because we will have terabytes and hundreds of terabytes of data. So we do have access to TOPCAL, which is the most performant HPC supercomputer in Africa. It allows fast processing time, massive storage, etc. And I would like to end with a very important note. We should not wait for the time of need to start to be prepared. And I did not want to give the cliche example of the COVID-19. Instead, a very good example and a shocking example is that of the Nepal earthquake in 2015. So Nepal was hit by a 7.8 degrees earthquake in 2015, and it costed the lives of 9,000 people, and around 1 million people were homeless. But then there was a national need at the time to identify the corpses of the victims. The country was not well prepared with a forensic laboratory to perform genomic data, or just genetic data in this instance, and it's not a very complicated kind of test to be done. So the country could not rely on its forensic laboratory, but instead relied on odontology, personal belongings, or just visual identification to identify and recognize the victims. And so we should not, what I want to say is that we should not wait for the time of need to start to be prepared, but we should be prepared beforehand so that we can answer to the specific needs of our country when our country needs a genomic intervention. So what I really want to say is a call for action, because we need multiple core laboratories, not a single one. Examples of the Singer Institute or Imagine, for instance, these are massive core facilities that do answer to the needs of their community and the needs of a whole continent, if not samples from the whole world. Unless there is a dramatic increase of sequencing and producing data from Africa and South America, there will always be an underrepresentation of our populations in genomic databases. Genomic core facilities are more than just scientific labs. They are key drivers of sovereignty, economic stability, and empowerment, and from here comes the need of having more than one. And by investing in core labs, definitely it is a very high and important investment, but it will reduce dependency on foreign services. It will retain the wealth of the country, because it will stop the hemorrhage of the hard currency, and it will build the scientific capacity needed for a sustainable future. And with that, I end with the picture of the very young team of the Genomics Core Lab at UM6B. And thank you for your attention.
Thank you, Professor Zinbershid. I would like to just mention that you are coming from UM6 Polytechnic University of Ben Gurion, but you have accumulated great experience at the Coast University, and then on the Liverpool School of Tropical Medicine, and also in, I think in Australia, Institut Cochin. Institut Cochin, oui, voilà. Donc, so the current slogan
now is one size doesn't fit all. I agree. So we should be prepared for anything that will come on the future with core facilities, with great expertise, with new tools.
Definitely, especially that we know that the next pandemic is just a matter of time. So it's better to be prepared now and have our own tools ready to be utilized when the next pandemic hits.
Yeah, that's right. And recently, Moroccan team have published a whole genome of Moroccan population of 109. Yeah, a Moroccan genome. So that could be help in the future. Yeah,
definitely. The need of the numbers should be much more than 109. I mean, we're really severely lagging behind other countries, and the lowest that I know starts from 1,000 and something. And here I mentioned just small countries in Eastern Europe. But we do need a more federal effort of different groups of scientists and teams of scientists from Morocco to be able to say that we do have the Moroccan genome. Starting with 109 is a very good start, but we definitely need more.
Yeah, that's true. Effectively, I'm from University of Science and Health. Right. We should manage our efforts and do better. I think we will move over than 109 with the other projects on genome sequencing, so we can manage our effort to get more results and more reliability about genomic sequencing in Morocco and medicine. Precision. Well, so the question, is there any question? Yes, please. You do.
Thank you. What do you think about all the personal tests that exist now on the market, like 23andMe or Ancestry or MyHeritage? And do you think it's an opportunity to gather some information in one way or another and work on that to find new treatments, for example, or disease, health, as you mentioned?
Definitely. Well, yeah, sure.
Qui est le micro? Je profite du micro. Merci beaucoup pour votre excellent travail. Et je vois votre militantisme pour l'Afrique. Alors, moi, je voudrais vous demander, vous savez que le Maroc est en train d'implémenter le protocole de Nagoya, et un chercheur comme vous, on en a vraiment besoin, parce que je ne sais pas si vous connaissez le groupe qui travaille sur le DSI, Digital Sequences Information, ça serait très bien que vous rejoigniez un petit peu le groupe avec tout votre savoir-faire. Voilà. Merci beaucoup.
Merci. And I will come back to the question of 23andMe. I do not personally think that it is of the highest value possible for underrepresented populations, simply because we do not have enough data in the databases to compare to. I mean, if you perform the test, you will see that you are 5% Ashkenazi, 20% European, etc. But we do need a very solid background behind to be able to say that this is what we classify for. Now, I will go just one step even further. What is more important is to know what are the different kinds of VUS, like the variants of unknown significance, and what are the markers that can help our own populations classify as within a risk factor, for instance, for developing a specific disease, or even later on, after the development of the disease for diagnosis. We do need also markers for predicting the prognosis of some specific diseases. Now, the problem is that in the absence of data, we cannot seek answers from data already published for people of European white Caucasian descendancy, because there is a huge difference between how the markers perform for Europeans, for instance, because the Caucasian ancestry is the highest ethnicity represented in databases, and people coming from Africa. People from African descendants do score more than 80% less well than people from Caucasian ancestry when it comes to the same markers that were developed from the databases so far. And it's the same thing for Asians. I think Asians, it's between 40 and 60% less. So the need for developing our own data sets does exist, but getting the data from 23andMe, honestly, I do not know who owns the data, but I think that it belongs to 23andMe or to Heritage if you go to one or the other. I'm not sure, I did not send my samples before, otherwise I would have read the consent, the informed consent form. So we do need, and this is the point that I talked about for the informed consents, because the common person does not know the depth of what can be done with the data and how it can be used, and if it can be sold later on or not. All they're interested into is getting the test results. We do need to read better the consent forms, and honestly, I also doubt that if the property of the data is mentioned explicitly in the consent forms. But I do doubt that we can get that data. Usually pharma gets the data from 23andMe and others, and there has been gates. There has been gates before for selling information to pharma.
Another question? Please.
Yeah, thank you very much. Very interesting. As somebody who chaired the UCL Research Ethics Committee for 7 years, and now I've stepped down, but one of the last things we had was exactly a problem associated with genomics and Nagoya. And I think I'm picking up in part the issue raised by the previous question. Mm-hmm. The issue is there was a East African country where some research was conducted by a college of the University of London, and we could not get the material to the UK, basically because of the requirements of Nagoya. Mm-hmm. Which in a way is absolutely paradoxical. It's counterintuitive what the idea was with Nagoya, keeping in mind that obviously what you just said about empowering the participants and everything is absolutely crucial. So my question is, how can you support a strategy to overcome this? And what would be the situation if it would be a collaboration between an African country from, let's say, the eastern part of the continent and Morocco? Thank you.
I do think that this is the best way that we can intervene. And probably later we can sit together and discuss the details, because we also have the director of the center here present with us, and we could discuss the details. But the core lab, the UM6P core lab, has as a mission to empower Africa and serve Africa. And this is definitely something that we can come to the help. And we've already started receiving requests of performing some tests for African countries, because Africans always prefer the South-South collaboration and sending the samples to African countries instead of sending to Europe or to the US. So yes, it definitely falls within our perspectives, and we can collaborate about that perfectly.
Thank you, Professor Zineb Rachid, again for your nice presentation.
Thank you for having me.
For the future of Africa.
Thank you.
Thank you. Please, thanks, Professor Zineb. Now we move to the next presentation to my colleague.
So from the West valorization and to genomics exploration with Professor Rachid, now we will start another presentation about artificial intelligence, innovation, and clinical trial with Professor Long Xiaomin. So Professor Long Xiaomin is coming from Sunna University, Malaysia. He is the Deputy Dean of School of Pharmacy, and he has a big experience and extensive academic and research experience in pharmaceutical science. He has previously held academic position in Australia and other countries. His research group is engaged especially in clinical pharmacy and clinical research. Professor Lang has successfully lead registration and commercialization of pharmaceutical products, including cosmetics, medical device, and medications. In 2023, he was appointed as parliamentary advisor on the Tobacco Product Control and Public Health Bill and served as co-chair of the Policy Committee Tobacco Control of the International Pharmaceutical Federation. Thank you, Professor Lang, for accepting our invitation.
Thank you very much, Prof. Hakim, and also the chairpersons. It's my great pleasure to be here. Thanks again for the opportunities. So in the interest of time, I think we are quite a bit behind schedule. I'll try to speed up my talk. Okay. By my talk, mainly will focus on both the drug discovery and also the clinical research. Okay. This one just to showcase where we're from. I'm also very proud that Malaysia is also part of the ICESCO. So you can see the Malaysia map here also. How far is it? We are coming from by flight almost 20 hours. Okay. So there will normally the whole journey, but it's really worth it. We really love Morocco and also such a hospitable country. Okay, so let's just look at the questions. Okay, in currently we are living in the era of AI. It's very exciting. There's a lot of new drugs have been produced. Okay, new small molecules. There's a lot of breakthrough in the research in terms of drug discovery. But then there's a question that is there a place for AI in biological and pharmaceutical sciences? Definitely yes. That's going to showcase that. And also, are we thinking that our role, can it be overtaken by AI at some point in futures? Okay, this one I'm going to explain later, also based on the propositions by Bill Gates. Okay, so we see different predictions made about AI in futures. So AI have become more commonplace in research, and also researcher will be able to spend, sorry, I forgot to, yeah. Sorry, I forgot to press next, yeah. Thanks for raising a hand. Okay, so if you can see here, that is the I suppose talking about this one, okay. Okay. Following will be the opportunities that AI can give to us at this time, because there have been a positive impact on the reductions in mortality rates. AI can help improving the efficacies of disease diagnosis and also management and treatments. I'm going to show you using 2 case studies based on Alzheimer's disease and asthma. And also the markets for AI have potentially to improve the healthcare outcomes. This is very conservative, 30 to 40%, and also it won't necessarily replace, for example, clinicians or researchers, but it allows us more time to focus on what our best doing, okay, or our core research. Okay. The increase in the use of AI have been driven by successful use of, this is the 4 examples stated here, application of deep learning. I'm going to show you what is deep learning. Increased neural network, increased understanding and development of different AI algorithm, and increased use of algorithm. So what does it mean? Maybe 10 years ago it doesn't make sense, but then now with AI, also the previous speakers, Prof. Zena also shows ChatGPT's generative AI. Okay. So in traditional practice, as a clinician or clinical trials, when data is being collected, then it will be stored and also then will be analyzed. Nowadays, with the use of machine learning and AI, then we will be able to fully utilize AI to support us for further applications. So let's take a look at, I'm sure this one has become very familiar to everyone now. Okay, you have the first one at the broader level, AI which is development of a smart system and machines that can carry out tasks that typically require human intelligence. At more narrow scope, machine learning that can create algorithms that can learn from data and make decisions based on patterns observed, and also, but it requires human interventions when there is an error. Okay, so the currently very focusing AI, the deeper level will be the deep learning, okay, which uses an AI or artificial neural network to reach an accurate conclusion without human interventions. So now it's also fully used in drug discovery. This one just when I do literature search about use of AI in Morocco, I saw this paper. I thought this would like to share with you. So this was published last year and also by a group of researchers at Mohammed V universities. Okay, so from their studies also they come up with what they call as the LAFBA AI framework, which is based on the surname of the two authors here. So they foresee that the Morocco also fully embrace and also catching up in terms of use of AI in various sectors. Okay. Okay, next, this one just to show the application of AI as you see from the titles in drug discovery and also in clinical research. And drug discovery also involved both in the drug design, drug screening, and if for clinical trial design and monitoring, we're focusing here on the subject enrollment and the selections and also patient dropout and also monitoring of trials. Okay. I'm sure everyone is also very familiar with this one. Just to show that with the use of AI, we'll be able to cut down the drug design and developments from 6 years to average less than 2 years. So from the drug targets, identification, validations to lead optimizations using deep learning. This one just to highlight my PhD students' previous work on the comparative analysis of endocrine and chalcone derivative-based virtual computatory library, which we also use keen informatic concepts to apply, which is integrating ITs and also combining manipulation of chemical data, including small molecules and also structures. Okay, broadly speaking, when it comes to AI algorithms, we can look at the three potential applications. First one is to identify the new drug targets, design the novel molecules, and also predict drug efficacies and safeties. So the third one will be also discussing using the example of Alzheimer's disease and asthma disease. Okay. So it applies across basic biomedical research, experimental pharmacology, and also clinical practice and research. So if it shows from this spectrum of activities, right from the basic biomedical research up to clinical practice, as you can see here, target identification, drug discovery, also cellular responses, animal models, electronic health record validations, and also clinical trial. Okay. So the following slides will be based on this particular review paper published in Cell Reports and Medicines. They are talking about AI and open science in discovery of new medicines for Alzheimer's disease. Okay, as you know, Alzheimer's disease is one of the, with the aging populations, it's one of the critical disease to be controlled or to be treated. Okay. So here, this is let me show the first part of the AI algorithms here. Here first part shows the input of the data. So the input of data can be through multi-omics, including transcriptomics, epigenomics. Okay. So if you see the middle here, you have the representations molecule. It can be either 1-dimensional, 2-dimensional, or 3-dimensional. And also in terms of input data using networks, it can be drug networks, drug disease or drug genes networks, okay? Then followed by that, we also have the AI algorithms, okay? So combined with the input and then analyze using, for example, different AI approaches, including machine learning, recurrent neural network, graph neural network, and also VAE. So for the output, as you can see, in order to produce new molecules by using this application of AI methods in the Alzheimer's disease drug discovery, okay, predicted drug target interactions associated with Alzheimer's disease, okay, can be performed. So just a summary as what being shown in the flowchart. So the AI play a transformative role in drug discovery and development, which enables the rapid analysis of a large biomedical databases. Okay, it also enhances our understanding of disease mechanisms by integrating complex biological information. Application of AI in pharmacology range from target identifications to clinical trial design and optimizations, and also AI will be able to integrate multi-omic data, which I mentioned just now, the genomic, transcriptomics, or proteomic, metabolomics, to potentially identify new drug targets. And also using machine learning models, it can predict biomarkers and disease pathway that may contribute to Alzheimer's progressions. Okay, moving on, let's take a look also on the clinical research impact of use of AI, okay? So here's stated that the AI enhances the patient stratifications. So let's say, for example, you have the patient's data sets from the previous clinical trial, okay? Then you can also using machine learning methods to help to do the patient stratifications that can help to also combine the genetic information, clinical and imaging data. Okay, the AI will be able to help to come up with one new subgroup of analysis, which can potentially give a new perspective to the clinical trial data set. Okay, so also now the pharma company also look into the regulatory agencies looking at the real world data from, for example, hospitals outside clinical trial. So it will be able to leverage to predict the treatment outcome and refine trial designs. Okay, AI-driven digital monitoring also ensures continuous safety and efficacy assessment in real-world settings. So these ones I'm going to explain later using asthma. Okay. So as you can see, AI-assisted electronic health record analysis have been used to match the clinical trial participant with appropriate eligibility criteria, and also machine learning-based clinical trial emulations identified Zolpidem. If you are a medical doctor or pharmacist, you are quite familiar with the Zolpidem, which is the trade name is Stilnox, which have been marketed more than 30 to 40 years ago for treatment of insomnia. That from machine learning based clinical trial simulations, they have somehow find that Zolpidem could be repurposed for the treatments of Parkinson's dementia. Okay, and also AI power multimodal analysis showcased just now using Alzheimer's disease, integrating all these informations that can improve also early Alzheimer's disease diagnosis and progression tracking. So let's take a look at AI in clinical research based on the asthma. Okay. So let's imagine that you have the existing 1,000 patients records that have multi diseases, including asthma. And then now the ultimate aim is you like to use AI to help you to analyze the data to classify it into based on the asthma status. Okay, it could be, for example, whether the patient is having moderate, severe, or uncontrolled asthma. Okay, so from the electronic health records, there are two types of informations that can be derived. First one is the unstructured data, which is the clinical notes, okay, and also the structured data, which is including the numerical informations from lab, for example, the patient's peak flow readings, or also patient provided informations, including their age, okay. So for a clinical note, which is here on the left-hand side, you can see on the unstructured data, it can be analyzed using natural language programming, text processing, and also then will be integrated together with asthma-related concepts, looking into, for example, classification of certainty, what is the asthma status, and also what are the roles of this particular patient group, okay? And then it combined together with the patient level classifications based on the patient's established guidelines for the asthma criteria. So they will be able to group the asthma status accordingly. Okay, so this is it's very quick with a few click of buttons that will be able to generate such informations. So here, just to further illustrate the different category of data that can be input based on the, in this particular case, based on the clinical notes, for example, problem list, clinical notes, care coordinations, medications of the patients, previous visit informations, and also lab data. Okay, all these things then will be able to utilize in terms of the reportings, decision support, and also clinical research. So just to highlight that from my readings, so what was proposed by the AI expert is the changing. The change is happening at a very rapid pace. The data have been generated or published last month could be outdated already because there's so much new information coming out, especially now with the new area in data science. So our decisions should be based on the correct and factually based data. How to achieve that? As researchers, we need to also keep updating ourselves, okay, with the most accurate treatment and also decisions to ensure that we can achieve a correct decision making, the latest one. Okay, the informations that need to be reviewed very, very frequently to make sure that it is up to date, and also the data collected, also you need to make sure that is it a real clinical data or is it the AI generated simulated data. So this is my last slide. This is the questions we need to ponder upon when we use AI, okay, in terms of the ethics and also who should be held responsible, okay. So AI data and recommendations must be verified, so that the researcher have the full autonomy or a full responsibility at all levels. Okay, who will be responsible for incorrect data or incorrect recommendations? This is a question for us to think. Okay, would it be healthcare professionals, researchers, or the AI system have to blame? Okay, how are discrepancy in judgments? Okay, versus AI handler, okay? How we should tell the patients what how to reach the final decisions. Okay, with that, I end my presentations. I will again acknowledge the Congress Chair, okay, Prof. Badro, and also Prof. Dr. Hannah, and also organizing committees for giving me a chance to visit this beautiful country. Thank you so much.
Thank you very much, Prof. Long, for your nice presentation. now the session of opening question. Yes.
Yeah, thank you, Dr. Longer. Absolutely fascinating. And you confuse me even more about what we can do with AI and more importantly, what not. Now, I'm picking up your last point. How can you make AI responsible if something goes wrong? In the end, that must go back either to a company which implemented the technology, or it must go back to a person who used AI to make the decision. So I think this part, you can't blame your laptop if your presentation goes wrong.
Exactly.
But it may be a technical fault. So how do we handle these responsibilities and the ethical obligations behind it? I would be really interested in your thoughts on this. Thank you.
Thanks. Excellent points. So I can relate for example, during COVID, so the New England Journal of Medicine's withdrawn one particular papers on the hydrochloroquines for the treatments of COVID-19. So this sparks a new controversy or a new concerns that who should have responsibilities towards the data presented in our or it could be in clinical trial or in our clinical research. This one somewhat aligned for what you have mentioned, because who then will be responsible at this point? Like using that example, now when we're submitting our manuscripts for journals considerations, they put a heavy emphasis now. Who is the guarantor for the data? Where this data coming from? Then they want us the data to be, for example, safe in the on open repository. Similarly, I think in near future, which is also a lot of dialogue have been ongoing, to see that when we generate the data or the data or how we use it, okay, there should be and also standardized, for example, guideline to say that when we report some things, that the data, is it AI generated, or is it what is the particular case? Is it a real data or generated by AI? So in the case, I don't have a correct answers for you, but I think in near futures, more guidelines, firm guidelines will be also being have to be adhered to or will be proposed. Okay, thank you.
The next question.
Thank you very much. Delighted again to meet you here. And concerning or relating to AI use in drug discovery, I think, and you might also just enlighten us about this, the area where AI can take part is still in the area of structure identification, maybe proposing bioactive compounds. But then when it comes to developing testing drugs, maybe in human, observing side effects and all associated problems that might arise, I think still this will be a total human work, and it will take a long time. And I think it should take a long time because, I mean, what happened, for example, in case of COVID, it cannot be taken as a standard for all the others. Now, this is one point. Another thing is, I think maybe AI can play a very important role in reproposing biological activities of the current used drugs, maybe. I mean, if we are looking for safer compounds to use, we should focus on something that's already proven to be more safe or relatively safer than other compounds. So I don't know, but I think there AI might play a very important role in maybe understanding, proposing, analyzing chemical spaces, structure activity relationships, because I think we have millions of compounds. So it might be taking good part there. So would you please?
Yeah, I good point, Asaf. So the what you have mentioned also they have FDA also have added those informations in their latest guideline on the when we report in clinical trial or what is the potential use of AI. So that is very good point. Yeah, thanks. Okay.
Another question?
Thank you very much. It was very interesting and promising. What AI platform do you use, or platforms, maybe several? And do you train through the machine learning or AI platform with your own data? And how do you secure this, or do you give the data and then it can be used to train the AI for other purpose?
Yeah, good point. So currently we work with another IT company. So basically they're still based on the API provided by the ChatGPTs. No? Yeah. So it's still very much based on the OpenAI platform. Yeah, thanks. But might be also it will be interesting to compare, for example, OpenAI platform and also DeepSeek platform to see that. But there's a lot of different company also coming out with their AI platform. But so still much more to be done. Thanks. Thank you.
Any question?
It's almost time for, we still have another presentation, Prof. Asa, before the poster presentations. Okay, go ahead, sorry.
Well, I'm going to ask you very quickly, actually. Thank you for this fascinating presentation. Your work demonstrates a sophisticated integration of AI into complex domains, specific systems like drug discoveries. I want to ask you about how you navigate through the challenge of merging into two different domains like coding and algorithm and your pharmaceutical analysis, knowingly that software engineers may not have enough expertise in pharmaceutical sciences. How do you manage the collaboration or the knowledge transfer between these two different domains?
Oh, thanks. It's very interesting points. So I also supposed to mention just now, so according based on the report by Bill Gates, he proposed that there are 3 types of area, which is just like you have mentioned, that cannot be currently he foresee will not be replaced by AI. First one is coding or coder. Second one is energy research. The third one is biological or healthcare research. So I think these 3 core areas have true multidisciplinary collaborations. So now if you see all the pharma or effective drug discovery research centers, they have all these expertise together, working together. Or do you have also, for example, medical doctors that take up a PhD in IT or AI, or for example, biological researchers that specialize in AI, then further study in medical degree. So in a way, it can be through the same person with multiple skills or different people working together as a core team to pool their resources and knowledge. So I think that will be very helpful to speed up the whole drug discovery process. Thank you.
Thank you very much, Professor Long, for your response. So to the last presentation with Professor Asad Khalid, who is coming from Saudi Arabia.
It's going to be my pleasure. So, ladies and gentlemen, just join me to welcome our next presenter, Professor Asad Khalid from the University of Jazan from Saudi Arabia. It's my second time to welcome you to Morocco, to Rabat, to the ICESCO. It's always a pleasure and honor to have you within us. Professor Asad Khalil is a pharmacologist, phytochemist. He worked plenty on characterizing phytochemicals that may have inhibiting activities in enzymes. specifically in one enzyme that implicated in neurodegenerative diseases like Alzheimer's disease, which is the acetylcholinesterase. So Asad Khalil, during his career as a distinguished researcher, he characterized like hundreds of molecules that may have activities in inhibiting enzyme and that may have potential therapeutic effects in several diseases, including Alzheimer's and malaria disease. So, Professor Khalil, the stage is yours, and thank you again for sharing your experience with us.
Thank you very much. Okay, great. Thank you very much. You can't imagine how much delighted and happy and to be here in my almost second country, and in the first country of my two kids. Whenever I'm traveling, I usually take 6 passports. We are a family of 4 people. Me, my wife, and my 2 young kids. So whenever we are traveling, I carry 6 passports with me. And this is because my 2 kids are holding 2 nationalities. So they have a Sudanese passport and they have a Moroccan passport as well. And I'm very happy, in fact, to be among my colleagues here for the second time. Yes, I was really quite very close for missing this conference. I missed the first day, but I am happy that I made it to attend the conference and to stand in front of you here and to discuss this interesting talk and discussion about drug discovery. This time I really incorporated my area of expertise, enzymology and enzyme inhibition, because this is where I really got introduced to drug discovery. So some of you saw a few slides of my presentation in the last conference, because I think these slides maybe form pillars or strong stance in drug discovery. One of them is this one. And in fact, we should always remember how much challenging it is to discover and to develop a drug. And this is what I was just mentioning too long, because really drugs are extremely difficult to develop. It takes till now about 12 years. We don't know how much AI will contribute to expediting this process, and it will cost something like 1.5 billion US dollars as an investment. And there are very, very few chances of getting any bioactive molecule that enters in preclinical stage into the shelf of the pharmacy as a drug. And again, I did the same mistake that long I didn't press. Okay, good. Okay, so I was just talking about this, that the drug takes around 12 years to be developed. It is an investment of 1.2 billion, and there are very few chances for preclinical or any drug in preclinical stage to get into the pharmacy shelf. And even though there are very, very high profit of tens of billions of dollars behind every drug. That's why, in fact, we have mega pharmaceutical companies that are working in this area. But still, we have a very big global gap in the healthcare world. And if you can see here, there are almost 1% of the drugs being developed by pharmaceutical companies that are devoted to the diseases prevalent in the poor north or poor countries, the diseases that are related to, in fact, developing world more than the developed world. And this is because, as I just mentioned, pharmaceutical companies are in fact driven mainly by their interest in profit. And again, working in some diseases like the poor countries or the poor region diseases sometimes doesn't guarantee even covering the cost of the drug. And in fact, it is simply a fact that pharmaceutical companies are not interested. And that's why academicians should work on drug discovery. And this is now, in fact, what is happening. For example, this is one project we got funded by about 6 million by EU. I was a part of this project representing Sudan, and we worked, in fact, along with 11 other counterparts from Europe in developing some compounds for neglected parasitic diseases. And why this is important? This is important because only EU, only WHO are the real strength behind funding research in this area. As I said, pharmaceutical companies are not interested, so scientists from third world countries and scientists from all over the world are getting interested in drug discovery, and they should, in fact. Coming to drug discovery, we can target different diseases by different drug targets. And these drug targets are, in fact, falling into different classes. The most important one of them, the most important drug target is enzymes. Enzymes, in fact, represent, or enzyme inhibitors in use in clinical pharmacy or in the shelf of the pharmacies. They represent around 50% of the currently used drugs. Then we have receptors, and then receptor drug targets, for which we can see many agonist and antagonist drugs in the market. We have nucleic acids drug targets. We have some ion channels and some transporters drug targets. Now, this is why I got interested in enzymes. And again, just because enzymes as drug target, we can simply handle in our academic research labs and in our university research labs. And again, when looking into different diseases that can be targeted by enzymes, I think you can see tens of diseases that can be targeted by working on enzymes and trying to discover enzyme inhibitors.
Just you switch the slides here. Just forget about your laptop and just switch the slides. Yeah, so we can follow with you. Exactly. Thank you.
Oh my God.
No, it's okay.
I'm sorry, everyone. I was just talking about the importance of enzyme inhibitors as drug targets, and that enzyme inhibitors, in fact, represent 50%. So I will look this way. I will close my monitor because. Okay. So enzyme inhibitors represent 50% of drugs in clinical use, and that's why enzymes represent 50%. I'm not going to repeat everything I just said. Okay. So starting from here again, as I said, if you look into the list of diseases that can be targeted by different, by working on enzymes as in drug targets, you can see that we have tens and tens of diseases, starting from hypertension up to bacterial and parasitic disease and parasitic infection, hepatitis, malaria, whatever. The list is so long. So enzyme really represent a very important class of drug targets that we can really work on. Now, talking about what we do in our lab, first of all, I should say that we are very simple, yes, maybe active, but we are simple research group. We work in collaboration with different scientists within our university and also internationally who has different related expertise, and that's why I just talked about, or I put this title as integrated disciplines in drug discovery. So what we do screen traditionally used medicinal plants. We collect them, and utilize the traditional knowledge, and we collect the plants and choose the plants mainly based on the traditional knowledge. We do screening, and then we try to identify enzyme inhibitors or enzyme inhibiting bioactive compounds, and then we try to explore molecular recognition pattern or structure activity relationship. We try to assess these inhibitors in cell lines or parasite culture or parasite or bacterial culture, whatever we are dealing with, and at the end, whenever possible, we try also to assess and to examine these compounds in vivo. So currently we are just dealing with a variety of enzymes. First of all, malaria and toxoplasmosis. We are really targeting it through in oil ACP reductase, what's called ENR in case of Plasmodium falciparum, and glycogen phosphorylase for diabetes, cholinesterases, acetyl and butyryl cholinesterases for Alzheimer's, alanine dehydrogenase for Mycobacterium tuberculosis, beta-lactamase and trypanosine synthase for trypanosoma and trypanosomiasis. So we also do some antioxidant assays, but we have one very interesting cell-based assay for TB, which I'm going to discuss a little later. And we keep on adding different enzymes whenever we have students, whenever we have also financial facilities. Now, going back to the traditionally based knowledge of collecting medicinal plants, why do we do focus on medicinal plants? This is because, in fact, medicinal plants has given us almost around 70% of new drugs, and again 80% of antimicrobials and 75% of anti-cancers. These are all medicinal plants or natural product-based compounds. Now, and the main reason that makes natural products stands as a very important player of in drug discovery is in fact the structural diversity, because in fact the diversity of chemical structures which are found in nature is totally unmatched, and it cannot be met by any imagination of a synthetic chemist. And again, there are some, we know that there are some, and there are many natural product structures that are very difficult or impossible to synthesize. Till now, people, when they are trying to market a drug, or even whenever they are trying to modify a drug, they have to go back and isolate these plants from nature. Now, I'm going to talk about the impact of structural diversity, and this is in fact in the hit rate, high hit rate of these medicinal plants. In papers, in literature, you will find usually that the hit rate of medicinal plants can be 1 out of 125. So it is almost 1%. And this is in fact, or 0.75%. This is in fact what is written, and this is true. But based on our own experience, this is not usually the same all the time. Sometimes the hit rate might go up to 5% in some cases. It depends really on maybe the enzyme you are using, maybe the drug you are targeting, because we can see different hit rate based on also the specificity of the drug target that are being targeted. Now, this is totally different story when we compare it with synthetic compounds. The hit rate in case of synthetic compounds is extremely, extremely low. Okay, now this is very important because we are here in Morocco and I'm coming from Sudan, and in between I'm also now coming from Saudi Arabia. All these countries, all the region share one thing. We are in fact the owners of the wealth of the natural product. If you just see the map of Morocco and you just see the climate diversity you have, you see the soil diversity you have, you see every diversity you have, and you see the impact of this diversity on the production of different plants. I'm talking about, just see, I mean, I know in Morocco, for example, there are different plants that even we eat every day, and every one of them come from a different area and from a different direction. Exactly, this is the same thing. This is the same story that what nature does. When it comes to medicinal plants, this diversity also generates a very diverse medicinal plants in our region. So we are really the owner of this wealth. There is a unique blend of indigenous culture of Islamic, Arabic, and African cultures in using these medicinal plants for health purposes. Climate and soil diversity, as I said. Now diverse virgin and virgin flora. Our flora is rarely explored. And unbroken tradition of use, as I said, available human resources. We have human resources in our countries that really work or related to natural medicinal plants. When we talk about plants from plants to drug, the journey of the discovery of drugs from plants, this is a very simple diagram that it starts with the plant, it goes to crude extract. Some people usually they can screen also crude extracts. There is no problem in that. This making them also don't miss any activity in between, or otherwise go for pure or semi-pure or fractionating the medicinal plant, so that ultimately also they can check it. Ultimately, of course, we can target the molecular structure in our journey. A lot of people now, the modern way is to do bioactivity guided isolation or separation. This, with the help of modern techniques like preparative HPLCs and some modern techniques like this is really now playing a bigger and bigger role in drug discovery. We can again extract the crude extract, or we can involve also chromatography in between, in the middle of the drug discovery process, so ultimately we can reach to the identification of pure compound. Now, when it comes to screening options we have, we need to know that we can either screen extracts, and we can do the screening in cell assays, and in this case, we would not know the hit, and again, we would not know the drug target that is that's underlying the activity, but definitely we would not miss any bioactivity of the extract if we just do the screening in cell-based. In case we used target-based assays, target-based, I mean in case we use pure enzyme or pure protein, then definitely, again, we would not know hit, because, again, that is an extract composing hundreds or thousands of compounds, but we would definitely know the exact mechanism or the target name and structure, and we would not miss a lot of bioactivity, but of course, definitely it's not like screening it against cell-based, because there we will have a variety of drug targets involved. Now, when it comes to pure compound, if we do screening in cell-based assays, okay, we would know definitely the hit structure because it is a pure compound, and we would not know the target, which is that's involved in the activity, but definitely again we would not miss any biological activity of this pure compound tested. And in case we use pure compound in target-based, definitely the hit structure is known because that's pure. The target-based is known because that's also a single target, but biological activity will be, sometimes we miss a lot of biological activity in this process. It's a complicated story, and in my opinion, the solution would be, first of all, to screen pure or semi-pure natural product, not crude. And number two is to use targets of some drugs, some known drugs in the market. That's better than using any drug target that might ultimately fail in the further drug discovery process. Drug discovery is involving a lot of expertise, a lot of process, and you can see that it is, in fact, it can involve phytochemistry, in vivo bioactivity, in vitro bioactivity, molecular modeling, and in vitro cell culture. And this is what I'm going just to demonstrate quickly because of the shortage of time. From our own research, for example, it's very normal to find such a manuscript that really have chemistry, either synthesis or pure or natural product chemistry, enzymology, where we target pure or enzymes, like in this case acetylcholinesterase. We do in vitro, where you can do enzyme kinetics, classical enzyme kinetics, in vivo or ex vivo experiments to check the biological activity of the bioactive compounds. And ultimately, in between, we do also in silico studies just to explore in a good way the structure-activity relationship or the molecular basis of this activity. So this can start with molecular docking and end with molecular dynamic simulation, which is really very good. And now with the integration of AI, with the integration of very good software, very reliable software, this is getting even better and better. Now we can see that instead of doing when I started doing molecular dynamic simulation, we used to go for 10 nanoseconds. Now, minimum is 150 nanoseconds. And still, because of the development in software and in computers, this is also improving. Now, again, coming to the same philosophy and the same point, this is the real map of different diseases, 3 different cases of diseases, for example. The first one is malaria. And you can compare it, for example, with the WHO map that's being used. When you look into WHO map, you might understand that, oh, South America is also suffering from malaria. Maybe part of Asia is suffering from malaria. And Africa is also, along with them, suffering from malaria. But when you see the population-based or the affected population-based map from World Mapper, you know that Africa is the main suffering continent from malaria, and it's nothing similar to South America or even to Asia. So when you look also into drug TB, you know also that Asia also suffers from TB more. Again, Africa is also suffering from TB, but of course, Europe not, as North America, definitely not. And when you look into local tropical diseases, you can see again that Africa is also suffering more than all the other countries, all the other continents, and Asia is sharing pain with Africa, but definitely, South America also here come because of Chagas and some other diseases, but none of the others. And why did I put the map of malaria and TB? Because we have this enzyme, which I want to mention, enoyl ACP reductase enzyme, which can be used as a drug target to target both malaria and TB at the same time. In case of Plasmodium falciparum, this, in fact, fatty acid synthesis enzyme, this enzyme, which is involved in fatty acid synthesis, is available and is called BFENR. In case of Mycobacterium tuberculosis, it is called NINHA. So this enzyme, whenever we are working in the lab, we can use it as a single ball to target 2 goals, to target both TB and malaria, keeping in mind the difference in the structures between the 2 enzymes that's available in Mycobacterium tuberculosis or in Plasmodium falciparum. We discovered, in fact, one natural product, we like to call it R337, as an enoyl ACP reductase inhibiting. It's a coumarin, in fact, and it was isolated from a plant that is known to be an antimicrobial. People who does the screening of crude extracts, they identify this plant as antimalarial plant. But none in the literature identify this particular compound as the underlying compound behind the biological activity. Now, one very important thing is the IC50 of this compound is about 2 micromolar only. So it's considered as a very reasonably very potent compound. And we have done hit-to-rate structures, and we are working now on different derivatizations for this particular compound. We have done enzyme inhibition, classical enzyme inhibitions, just to identify experimentally the mode of action. We can do that, in fact, using a simulation, molecular dynamics simulation. We can do that also. We can do the same and sort of analysis using molecular docking, but both of these techniques still are theoretical techniques. We do always like to do enzyme inhibition, classical enzyme kinetic in the lab, so as to confirm experimentally this. Again, it makes a very important and good part. This is, in fact, what molecular docking and simulation tells us about the interactions of this compound and the site of interaction. And we just found that really it interferes with the interaction of the enzyme needed compounds. So this is a different story with another different ENR inhibiting coumarins other than the natural one. These are synthetic coumarins. So, for example, you can see that compound 15 is inhibiting this enzyme in a very good way and in a very strong way, similar to the standard drug. We know that coumarins, they are very interesting class of compounds. At least we have 10 to 15 coumarins in clinical use, some more and being developed in clinical trials, and that's it. This is now by mistake, I just wrote coumarins. It is chalcone, in fact. Acetylcholinesterase inhibiting chalcones. And you can see here the molecular docking. We have published this result with molecular dynamic simulation, with docking and with experimental techniques. And again, the same chalcones also were assayed against glycogen phosphorylase enzyme for anti-diabetic drug discovery, and it really showed some very promising effect. In the square in the right, you can see that this is the caffeine, which is a standard inhibitor of this enzyme. And in the first one, you can see 3 different inhibitors that are being docked with the active site constituents. Molecular dynamic simulations of the same compounds showed also very good interaction, very stable complex between the drug, the inhibitors, the chalcones, and the enzyme. Now, coming to a different story, which is not related really to enzymes, but something interesting we have found. It is antimycobacterium drug discovery. Just to mention in the first that not like any other bacteria, in which you need to come closer or get infected by thousands of bacteria to be sick. It takes only 3 mycobacterium, only 3, to enter your body, and it can cause tuberculosis. And this is because this bacteria is very aggressive, and when it goes into our body, it will be integrated into a natural host, and it will surround itself by a chunk of cells. So it will really hide from our body's immune system. And the immune system cannot really get closer so that it can get rid of this mycobacteria. The same stands as a challenge for drug discovery. When people screen antimicrobial drugs using just simple antimycobacterium culture, they are testing their compounds on exposed mycobacteria. And in this case, mycobacteria is usually like any other bacteria, easy to kill, easy to discover antimycobacterial for. But in the real world, these compounds, compounds that are being discovered this way, it will not work because of the real story or the real way used by mycobacteria to hide inside our body. Now, one day, in one conference, and that was in Tanzania, I was going through poster session, and I found one lady standing in front of a poster telling the story of how she succeeded in culturing mycobacteria inside the natural host, which is macrophages. So I just asked her about the assay, and she told me that she did this, and now ultimately in her lab, she have these mycobacteria inside the macrophages. So I just put a general comment. I said that this would be a very, very interesting model for testing different natural products or synthetic compounds for drug discovery. I think maybe the students herself was not aware of this fact. So at the last session of the conference, I was approached by her supervisor, Professor Maria Lerm. She was from Sweden, in fact. So she said, you came to my student's poster. She told me. I said yes. She said, I want to know your what did you say? So I told her that the model of your student would act as a very, very interesting model for testing antimycobacterium tuberculosis. So she said, can we collaborate on this? I said, yes, why not? So I managed to send one of my students 6 months later with about 50 extracts of 50 plants we collected using the traditional knowledge. This is how I started this talk. So out of these 50 plants, we discovered 5 plants that totally killed mycobacterium inside the macrophage in a fashion similar to the real scenario that happens in the body. So we processed these, one of the plants, like the same way we did a bioactivity guided fractionation. We used to fractionate the plants extract and test these plant extract in every step, and ultimately we did also the preparative HPLC assays. We got something like 100 more than 105 fractions, and we tested each and every fraction of these against our model, and what we found that fraction 95 was the most active fraction among all. This fraction 95, when we tested, it really came more active or similar to the standard drug that's being used. Now, we took also fraction 95, and we tested this fraction 95 among different strains of bacteria. We used, in fact, resistant and the standard bacteria, and the results that we found in the lab was really very impressive. This fraction was more active than even the standard drug in most of the cases. It was even active when the standard drug did not inhibit the resistant bacteria. So this is something we are now following, and we are really trying to patent first before we publish. And you can see that even this is fraction 95 in case of resistant strains, the red one, and the orange one is the standard strains. Interesting, really, and we are following that. Now, ultimately, I would just finish my talk with this musical slide. And I always like to talk about collaboration. I think the best example of good collaboration is what happened with, what is happening with, or what happens, in fact, what happens with the musicians on any stage. They collaborate, everyone produce a different noise, and ultimately a symphony comes out. And this is what, in fact, Brian Eno, a musician, said, collaboration helps you grow. So this is not the fact in music only. I think it happens also in our scientific work. Collaboration helps everyone grow, and collaboration helps us in producing better science. I am open to collaboration, and you are all welcome. And I cannot forget my collaborators, my students, and everybody who contributed to our research progress and development. And to you also, thank you very much for listening.
Thank you very much, Professor Asad Khalil. Now the stage is open for questions, if there is any question. Okay. A question by Professor Shahrazad. Hi, can you talk?
Thank you for your interesting and overview of your activities. I have a question on the coumarin derivatives that you mentioned. There are no to potentially give rise to covalent links among, as you are focused in this work on acetylcholinesterase, which is an hydrolase. So, have you find any covalent inhibitors in your pipeline, in your collection of compounds?
No, not really. None of them using our, of course, in vitro assays, in vitro enzyme assays, it was not visible. But when we did the structure activity relationship or simulation or docking, none of them seems to be producing any covalent bond with the enzyme. The thing is, usually, of course, you know, for the drugs, we used to focus on more reversible inhibitors rather than suicidal inhibitors. So
it depends on the application.
Definitely.
In the case of infectious disease, it may be interesting to have
something that will kill totally. Yes.
It's again.
But in case of cholinesterases, which is also a human enzyme.
Of course, you are right. Yeah.
No. This is what makes, in fact, the different Alzheimer drugs different from the gas weapons.
Yeah.
Both are enzyme acetylcholinesterase inhibitors. But in case of sarin and tabun, for example, which is used as weapons to kill people, acetylcholinesterase drugs used to treat people.
But sometimes it can be also interesting to have covalent molecules to derive activity-based probes and something like that to make imaging, and there is some. Thank you very much.
You are welcome. Thank you.
Thank you. Any other question?
So, hello, thank you so much for your brilliant representation, which is very interesting because you are talking about drug delivery. A very subject to discuss because this can help humanity for reduce diseases, which can make a real challenge for researchers. So, my only question is about when you take plants and you prepare your extract, and then when we are talking about extract, we are talking about 1,000 chemical compound that can be exist there. About separation, which finally you get only one compound. How could you do this? Which analysis, technique analysis that you confirm that you have only one that you use?
Yeah, this is in fact interesting. See, I mentioned the dilemma maybe of screening crude or pure, and again screening them against single target or whole cell-based assays. In our lab, to answer your question first, we use normal chromatography, or it depends on the student who is working. So sometimes we have some students who are working with a target, they are just working on single plant. Their target is to discover new compounds from this plant. These are simply natural product chemists. Their main work, is a natural product chemistry. So they work on isolation and structural elucidation using NMR or mass and different other techniques. When it comes, so in this case, they use different chromatographic techniques, starting even with column chromatography to fractionate the plant first. Then they go for real some automated process using preparative HPLCs, and ultimately when they end with a mixture of few compounds, they go to TLC and some other things. So usually this is the path they do for this. We keep working with these students or natural product chemists closely. So whenever they fractionate or whenever they progress one step ahead in their work, we test for them the sample they get. So for example, when they give us different fractions, we test it. And we will tell them that this fraction is working, the other fraction doesn't work. So definitely they will continue because their focus is to isolate new compounds, not bioactive compounds. They will keep working on all fractions, but we will keep our eye only on the active fraction. And we would wait for them again to come to us after after fractionating further their product. This is now one way. When you come to a biochemist, for example, or somebody working mainly on a biological activity, we go directly for preparative HPLC, hoping like in the same we did the case we did with fraction 95, for example, I mentioned. So in that case, we directly went for preparative HPLC. Sometimes we go for HPLC normal or for GC even, to try to get some. We have a chemical library in case of our GC. Ultimately, we try our way. We try different ways to try to get a hint of what could be the bioactive structure, in fact.
Okay, thank you so much.
You are welcome.
Thank you very much. Thank you, Professor Assad. Now we'll just.
Probably I have one question for Professor Assad. I have seen that you make some tests in silico. So for in silico, most of studies work on active sites, which means incompetitive or competitive inhibition, but uncompetitive, it's quite difficult to do it in silico tests. You agree with me?
I definitely agree with you, and luckily we don't come many times across this. And this, in fact, mainly, this is what we come across mainly when we do classical enzyme kinetics. And that's why I love classical enzyme kinetics. And I always try to do it, and I always encourage my students to do it. They say that, okay, no, why don't we go for simulation and docking, because that's easy. But no, classical enzyme kinetics really sometimes tell us about uncompetitive inhibitors of enzymes.
Yes.
And in this case, of course, this is the only way by which we can discover this.
Thank you. I think we thank again Professor Assad, but you can stay with us because we call all the speakers that we got for the first session. Professor Hugo, please join us. Professor Ong Hui Shuang, please. Professor Zineb Rashid. Professor Assad Khalidi is with us. Professor Long Cho, and my colleagues, Professor Taha Kautar, Professor Saad Bekrim from Ibn Zahr University, Professor Bouihia, and of course, Professor Walid Aboussi. So we have some souvenir gift for our speakers. Hakim? Walid? So please join us here. Merci à l'audience, merci à nos speakers. Donc, thanks for the speakers, thanks for the audience. Now we have the coffee break session.
Hello, can you hear me?
Yeah, we can hear you. Mr. Ganesh, can you hear me?
Yes, I can hear you well.
Wonderful. Can you put on your camera? We cannot see you.
Yeah, just I'm kind of testing right now.
Okay.
Yes. Okay, can you hear me, right? You can see me, right?
Yeah, it's okay for the sound, but we cannot see you.
You cannot see me?
No.
I can see myself on the camera, but I don't know why you cannot see me.
Okay, we are going to fix it.
Choose video filter. Let me see the video filter. Green.
No, we still cannot see you.
Yeah, that's what I'm checking my end also. Possible things. So one good thing, at least you can hear me. So
Actually, I can hear you and see you, but from the IT desk, I cannot see you in the screen, the big screen of the conference.
oh, I got you. Okay. 1 second. Let me. Yeah.
D'accord. Can you connect and reconnect you?
That's perfectly fine. Let me try it again if possible now. If not, let's disconnect me. Okay. I'm going to leave you and I will rejoin. Okay.
Okay, fine.
Okay.
De toute façon, c'est déconnecté, je pense, d'abord. Il va se connecter. Prenez-le.
I think now you should be able to see it.
Not yet.
Not yet.
Maybe we
Okay.
have some problems here. We are going to fix it. Yeah, now we can see you. Okay.
Perfect. And you can see on the screen and on the.
We can see
Good.
it on the.
All right. Perfect. Okay. So problem solved. Let's me see the I have file sharing. Oh yeah, I have file sharing options. Okay, I can hear, sir. You can hear me. I can hear you. You can see me. I have option to share my files. So we should be good. Okay, good. Very good. Okay.
Yeah.
And now I have to read. No problem. Now I will put the mute and put my video off, and then I will start that time. Just please find me where I am in sequence, because I'm on a little bit different timing. So I just want to make sure I come on right time.
I think we have
Okay.
4 hours of difference between India and Morocco, 4.5. Mr. Ganesh, are you disconnected?
Sorry, I am mute. Now you should hear it. So right now you have a noon, 11:53, right? So when is my talk?
I think you have the program. Let me check. Dans une heure.
Now, fourth number. After Butena, I am going to speak, right?
Ganesh, exactly. Just after me, we have 2 talks, so maybe in an hour, okay? No, it's still the break. An hour and a half. Est-ce qu'ils ont fini la pause?
Maybe 2 hours. Now we are in coffee break, and then we have 2 speakers, and then she will be your turn. I think in 1 hour, 1.5 it will be your turn. Can you hear me, Mr. Ganesh? Hello, Mr. Ganesh.
Non, ce n'est pas le premier. Oui, ça marche. Alors, شهرزاد الحمري.
اييه
Parfait. D'accord. Oye, hay que se prepare.
Alors, s'il vous plaît, est-ce que vous pouvez rentrer pour qu'on commence? On est déjà en décalage d'une demi-heure. J'appelle tous les participants à joindre la salle, s'il vous plaît, au fond. Alors, pour nous préparer, donc, on va commencer la deuxième session de la deuxième journée. Nous allons être honorés par des présentations de Madame Shahrazad Lamari, elle est avec nous, Madame Boutaina Ghouri et le docteur Ganesh Halad qui sera avec nous à distance. Donc, si vous voulez nous joindre, professeur Ghouri, Boutaina. Alors, s'il vous plaît, donc on va commencer la deuxième session de la deuxième journée. Cette session sera modérée par professeur Khalid Tarzouzi, professeur Walid Aboussi. Se joindra à nous professeur Bouhia et moi-même, Souad Bni Aïch. Avec nous à cette session, nous recevons avec nous d'éminents enseignants et chercheurs, professeur Shahrazad Lamari, professeur Boutaina Ouri. Et sera avec nous à distance professeur docteur Ganesh Halat. So we start this session with the first presentation by Professor Shahrazad Al-Amri. Walid. Walid, please, can you come here to present Professor Shahrazad? Thank you.
Thank you very much. Actually, it's my privilege to present our first speaker in this session that concerns the health science, our Professor Shahrazad El-Amri. Professor Shahrazad come to us from Sorbonne University in Paris, the previous Marie Curie University. Professor Shahrazad, she's known for his work, especially and extensive expertise in Potier's enzymology, and which has like plenty of application in several pathological conditions, including neurodegenerative diseases. So, Professor Shahrazad, the stage is yours, and thank you again for joining us and sharing your expertise with us. Thank you.
So please, can you charge the PowerPoint, please? Okay. So thank you. I first thank the organizer, especially Professor El-Mankpalouti, for their invitation to participate to this symposium, which is not my first topic of research, but we are now in my lab particularly interested in developing anti-age and particularly xenotherapeutics strategies in the context of age-related disease. My topic will be to first present the challenges around aging, put an emphasis of the hallmarks of aging, and particularly senescence, and how natural product can help us to achieve this goal by presenting several mechanisms of action and presenting some of our recent results on piperlongumine conjugates. So aging is an universal, irreversible process that lead to particularly constitute a big challenge nowadays, since effectively the World Health Organization has, oh, sorry, I make the same mistake than the previous. So this constitutes a big challenge in the biomedical challenge, since as evoked by World Health Organization, the population by 2050 will have 2 billion persons age up to 60 years, which represents a real biomedical challenge by the increase of the occurrence of age-related disease, among which cancer, inflammatory disease, respiratory, and neurodegenerative disease, of course, which can give an important pressure on the medical systems. So the scientific objective of my team are to better understand the molecular basis of cell aging and inflammation in the context of chronological aging and age-related disease in a pluridisciplinary manner, combining drug design, medicinal chemistry, pharmacology to integrated physiology. And for purpose of prevention, therapy, repair, and regeneration. So I begin with the hallmarks of aging, which are of 12, and they represent, it's okay. So, and they represent different levels, genomic levels of, in the context of macromolecules, either DNAs, protein, organelle, and so on, but also integrative aspect like inflammation. And what is our interest here is, our interest here is the senescence that I will develop later. So aging in terms of molecular and cellular perspective. Oh, sorry. Aging in terms of molecular and cellular marker represent a disbalance between protective and accumulation of damages. It's better, right? Thank you very much. So in terms of molecular and cellular markers, it's represented this homeostasis between beneficial and detrimental factors, which during age we can observe accumulation of DNA protein damage, which is also as exemplified in neurodegenerative disease by accumulation of protein aggregates. And for this, it is really important to decipher different pathways that give rise to cell aging, to identify specific markers and specific therapeutical targets for intervention. When it comes now to cellular senescence, it's a natural process that is in response to stress. Senescent cells are also called zombie cells because they arrest their growth, but they are resistant to apoptosis, but they are still really metabolically active, and they accumulate over age, during ages, leading to inflammatory microenvironment that also participate to so-called inflammaging. That is a phenomenon that is well known during aging, that is also an important feature of many age-related diseases. So to give more details on senescent cells, so here you have a non-senescent cell and a senescent cell that is schematized here. You have a schema of non-senescent and senescent cells. Senescent cells have specific morphological aspects. They are generally enlarged with a nucleus that is expanded due to a decrease of Lavin B1, for example. They have also an increased lysosomal content, which is accompanied by a high activity of the beta-galactosidase that give rise to specific marker that you can see here in blue. You have also an increase of mitochondrial dysfunction that is also accompanied by a decrease of mitophagy, which is also a specific process that allows to eliminate mitochondrial debris, and importantly, a SASP, which is a senescence-associated secretory phenotype, that it's a cocktail of chemokine, interleukin, pro-inflammatory molecules, including also proteases and growth factors. this SASP is of great importance because it can lead to secondary senescence and is in part responsible for the deleterious effect of these senescent cells. So we can also say that senescence can be seen as a phenomenon that is context and time dependent. In early age, during embryonic development, it can lead. The lead one is neurodegenerative disease like Alzheimer, but also Parkinson, which are known now to have a high prevalence with age. Cardiovascular disease, pulmonary disease among the lead one. And what we are particularly regarding in this project is sarcopenia, which is characterized by loss of muscle mass, which is an important issue for old people. And it is important to have it, to find a solution for that. Indeed, during age, the muscle stem cell, we lose the potential of muscle stem cells. This condition is also found in certain pathological conditions, such as Duchenne myodystrophy. This is caused by elevated level of ROS and so consecutive to oxidative stress, decrease of autophagy. This impairs the appearance of these senescent cells, prevents proper regeneration, hence finding solution to selectively eliminate these senescent cells can be of a great interest, particularly in the context of muscle aging disorder that represent an archetype of age-related disease. So now what we call xenotherapeutics. Xenotherapeutics are some definitions, so we can either act on the SASP, which are the cocktail secreted by senescent cells that are deleterious for the environment. So these compounds are known as xenomorphic. They allow to attenuate the pro-inflammatory impact of this compound of these cells. Senolytics, as I mentioned, senescent cells lack of the lack of pro-apoptotic signaling. So, indeed, they upregulate anti-apoptotic proteins, so they are resistant to apoptose. So, any strategies that allow to restore this apoptosis, it can be seen as a valuable strategy. So, it was a mistake to put my computer here. So this compound have been validated in many using various murine models in the context of various pathological conditions, including renal dysfunction, metabolic disorder, and so on. So this was fine. So this has been shown in this model that eliminating senescent cells represent a great interest for the therapeutic of these conditions. So now let's talk about senolytics and how to eliminate the senescent cells. To eliminate senescent cells, we need to target senescent cell anti-apoptotic pathways. And you can see here a collection of compounds that have been already shown to be senolytics, among which we can find natural products such as quercetin and fecitin. And here in this organigram, you can see the current clinical trials that were in 2024. So what are the major drawbacks for the development of senolytics, which is the main goal of any people working to try to find a condition targeting senescence in age-related disease? Indeed, the limitation is the models. Sometimes we make it in vitro, but the main problem is the lack of selectivity between senescence and non-senescent cell. So it is why it is necessary to develop targeted strategies. Now back to natural products. So here you have a list of natural products, among which we can find resveratrol, lecithin, quercetin, piperlongumine, curcumine, and so on, and all are natural nutritional compounds that constitute high potential xenotherapeutic, but lack, unfortunately, of selectivity. They were found by high throughput screenings formerly, and now in the lab we were particularly interested in in the perspective of this project on piper alkaloid, the family of piperlongumine. So you can find here the representative members of this family that were shown to have a xenomodulating effect. So of course, all of them have been reported to have a distinct mechanism of action, either, for example, modulating AMP kinase, having an effect on antioxidant compound, antioxidant system, and piperlongumine, which is my object of interest, has several targets. So to sum up, we can see piperlongumine as a multi-pathway compound targeting oxidation-resistant protein 1. Oxidation-resistant protein 1 is responsible for the regulation of the biosynthesis of antioxidant systems, inhibition of HDACs, and more recently, inhibition of immunoproteasome. So indeed, it has been done much work on that, particularly to try to understand structure-activity relationship that allow to explain this xenolytic, xenomodulating effect of piperlongumine. It was really important to have an extensive structure-activity relationship to try to find structural factors that are responsible for this activity. So we can, that have been dissected out very deeply. So it was shown that the position of the methoxy in the phenyl group has no effect, but this double bond is really important. So we have to maintain it to have the xenomodulating effect. But in this ring, the identity of this ring can be, there is a flexibility in the identity of this ring. So now, taking all this in mind, how we can achieve the real selectivity for targeting senescent cells? There is many things to have in mind. So we can effectively block the pro-survival pathways. We can potentialize the immune system to attract immune cells to destroy these senescent cells like a pathogen. And also we can exploit what the so-called senescent cells surfaceome. So what we call surfaceome, it's the totality, it's the main protein representing senescent cells that have been identified as upregulated in senescence. So among which we can find the UPAR, DPP4, the dipeptidase-4. And in the context of my work, we were particularly interested in DPP4, which is known as a therapeutical target in the case of type 2 diabetes, for which FDA-approved compounds are already available. So many reports have underlined the importance of this marker, this transmembrane protein in senescent cell, as you can see here. this is upregulated in many conditions. So it is believed that DPP4 it's important in the activation of the cytokines that are part of the SASP. So our objective was to derive a library of bifunctional compounds that allow to achieve this selectivity by using natural products attached by a linker that can be also a trigger and a carrier that allow a selective targeting, namely a ligand of DPP4. So the trigger can be an enzymatic cleavage. As we know, proteases and esterases are really abundant in cells. We can also take advantage of pH microenvironment and also by redox conditions that are modified in senescent cells. For that, we design a library of broad senolytics. So here, just rapidly, so an enzymatic, pH sensitive nanocarrier, and the redox, the type of linker that we can use for that are present in the literature that have been already used in other fields that develop product strategy. And so we develop a bifunctional compound that merge inhibitors of DPP4 and piperlongumine to establish, to develop this bioconjugate that have been and then further evaluate on our system that modelize sarcopenia in vitro. So first, of course, we made some structure relationships activity. So I will skip all the synthesis because it's not my field, and I may not be able to explain all in the detail, so, but I only give you the overview of the strategy. So we can see here that the piperlongumine nucleus and the various modulation that we can achieve, and see what it is important to, because once we will link it to the other parts, there will not be this will not be deleterious for its activity. So these are the FDA approved DPP4 inhibitors that are subnanomolar inhibitors of high affinity that have been already evaluated, of course, because they are now FDA approved. First, we check for the proper binding of the inhibitor in silico. So this helps us for the design prior to the synthesis. We also, once we got the compounds, we also, so this is the example from one compound, which is one of the best compound we had. We found that an IC50, an nanomolar IC50 in the same range that the leader, the inhibitors, which imply that this bifunctional properly bind to DPP4, and this is also very selective because we do not have effects on DPP8 and DPP9, which are in the same family of DPP4. When it comes to the cellular evaluation, so we use two cell lines that are used for investigation on muscle, and so the MEF, the mouse embryonic fibroblast, and the immortalized C2, which are myoblasts, and use various kind of stressors to make them senescent, and we make all the checking to verify that they are indeed senescent, and then we check the cytotoxicity of our compound. There is no color. The color has disappeared, so trust me. So for the MEF cells, we can see that the bifunctional heat selectively kills MEF cells, whatever the stress condition. It is the same for the CD2 cell line that better modelize the muscle tissue. We also show that the bioconjugate is also promoting a promoter of apoptosis, as seen in this test tunnel, which is a well-known test of fragmentation of DNA that allow to give rise, to report the apoptotic state. So sorry, the color is not is not here also, but trust me. We also check for the ROS level and show that either piperlongumine and the bifunctional compound were able to increase the ROS levels. In a former study, we have shown that piperlongumine and some of its derivatives selectively inhibit immunoproteasome, which is the inducible proteasome that is present under inflammatory stress condition. That piperlongumine is able to selectively inhibit this immunoproteasome. That is also an important target in cancer and other inflammatory condition. So there is no color, so sorry for that. I don't know why. So we show that immunoproteasome is upregulated in senescent cells over normal cells. So you trust me. And then, so the color appear again. And we show also that piperlongumine and bifunctional compound were able to inhibit immunoproteasome in this senescent cells, which is an important feature that's allowed to achieve, again, more selectivity. So I am at the end of my presentation. So just to say that we were able to generate a small library of piperlongumine conjugate that present a trigger or not, but I did not present another candidate that is sensitive to beta-galactosidase that is in the trigger. We got a galactose, sorry, that allowed the recognition by the beta-galactosidase, which is really abundant in senescent cells. So we were able to develop a small library of piperlongumine conjugate, allowed to show that this conjugate, where some of them were able to enhance their selectivity towards senescent cells. This also allowed to underline that DPP4 is a valuable surfaceome marker and identify a multi-pathway effect of this compound, including ROS, mitochondrial respiration that I did not mention here, but we make also experiment on the mitochondrial respiration and also immunoproteasome. What are now the next steps? So we are continuing the development of this compound. This includes the possibility to use other natural products, other triggers, try to continue to identify selective biomarkers, try to derive xenoprobes, it is to say molecules that allow to monitor senescence in vivo, which is the next step, and finally, in a more time of the lointain, un temps plus lointain, we will develop a diagnostic agent that allow to simultaneously identify and kill senescent cell. So where we are standing, here are a table that represents the latest clinical trial status. So we can see here that one of the most how we would say blockbuster are quercetin and fecitin in the field, and they are used generally in a combination with dasatinib, which is a well-known tyrosine kinase inhibitor used in lymphoid, in cancer lymphoïde. Du coup, là, j'ai un petit trou. Myeloid lymphomes, okay? So you have here, they have been used in several conditions, kidney disease associated with, kidney disease associated with diabetes, in Alzheimer's disease, in various conditions, including also COVID-19, because it is known that also that viruses like SARS-CoV-2, but also other, accelerate the senescence of cells. So to finish, I would like to thank my team, especially Mazarine Dotou, who make a lot of work. She was supported by IBio Interdisciplinary Research doctoral program, and also Dr. Aurore Honoré, Dr. Roba Moumne for the synthesis of the compound, Anne-Lee at the Pasteur Institute for providing us the cells, and finally, again, Professor Hannah El-Mafaloti for her kind welcome and all the support she makes to me to attend this meeting. Thank you again, and I thank you for intention, and I would be happy to answer questions if you have any. Thank you very much.
Thank you very much, Professor Shahrazad Ameri, for this interesting presentation. So I return to the assistants, asking you if you have any question to Professor Lamri. It was very interesting, and personally, I learned many things about this presentation. Yes?
Thank you very much for the nice talk. Thank you. I want to ask you about, I have seen that you have done some structural modifications. Would you just, have you been involved much about nanonization of drugs, adding nanoparticles, something to improve delivery?
Not yet. So we are really at the first step to try to find, to have the proof of concept that our design is okay. Once it is okay, we wanted to go to, we are currently working on in vivo models. And then once we got a good disease modifying effect, we can perhaps see the next step. But I think now it's too early stage.
Too early.
Okay,
Yes.
Thank you again. Thank you.
There is any question? Other one?
No.
Yes?
Thank you, Professor, for this brilliant talk. My question is about biohacking, which is a huge subject now all over the world. What do you think about using natural ingredients and natural molecules to improve the whole performance of the body, but also for the degenerative diseases as diabetes, as autoimmune diseases?
I think, to my opinion, it is important to have a targeted strategy, because a holistic strategy is not always, especially when you want to develop a drug. So when you want to develop a drug, when you go with the investor and the big pharma, it will tell you which is the target. So you need the target. If you really have an idea, which is the case in many diseases, finally you have a multi-targeting. So you have the molecules that are multifunctional, that can that can modulate several pathways at the same time, which are involved in the pathology, which can make a synergic effect. I think we have to continue the research to try to better understand the mechanism of action of these molecules, system by system, depending of the pathology, try to modelize as deeply as possible the pathologies to find the best way to make better understand the molecular of the mechanism of action of these compounds. Yeah.
Thank you. Yes, there's Ilham Boris.
Thank you. Thank you for your nice presentation, many information about your molecules. For your derivatives of prepared longumine, did you pay attention to solubility of these derivatives, or you don't take?
Yeah, we pay attention, but they are potent or nanomolar, so it's okay. So we always prepare stock solution at 10 or around 10 millimolar in DMSO, and then we make the cascade dilution to be sure to. Okay. So at the moment, it is okay because they are relatively potent. Yeah. Okay. Thank you.
There is a question there to you.
Thank you for the presentation. I have a question about the uses of those natural products with anti-senescence properties. I mean, recently we see a lot of gellule pills or something eatable rich in resveratrol or pepper extract or something else. And we have also the cream, like to put on the hand. Or so in terms of pathways, which one is the most interesting one?
So I don't think I'm the best person to answer this question because it is rather a parapharmacy aspect. For myself, I try to find to work with pure unique compound and try to dissect out the mechanism of action in depth. So I don't think that, yes, there is an effect, sometimes it's placebo, but what we try to do is to exploit the first generation of senolytics that for some of natural products, for instance, and we try to make them having better activity and more in adequation with the drug development. Yeah, so it is, we can also make medicinal chemistry on this compound to improve their drug-like activity and so on. Yeah.
Thank you, Shahrazad. It was very interesting, and I learned a lot about xenomorphics and senolytics. I didn't know before. Are there any study about curative effect or preventive effect on senescence?
It's a big question because we know it depends of the pathology. Yeah, there is some pathology like arthritis that is now well documented, and we know that it's an important question because we don't know. Finally, really, it's really disease dependent. Yeah, because I mentioned it very quickly, but you have the primary senescence and you have also the secondary senescence that is engendered by the SASP. And if you stop or attenuate the impact of SASP, you can delay the apparition of secondary or tertiary and so on population of senescent cells. Yeah.
Okay, so in the future we can think about rejuvenating.
Yeah. It's some people are working on that, but there is several strategies also that have been also emprunté, how do you say that? That I've also used in the cancer field, like CAR T cells, PROTACs, and so on. There is other format that have been developed also. Okay, thank you.
There is a question here from Professor Roy.
Okay.
Thank you very much, Professor Shahrazad, for your fascinating presentation about this field of investigation. I have two questions. The first question about your targeted pathways.
Ouais.
If these pathways are canonical pathways, this is the case of mTOR targeted by
Yeah,
rapamycin.
Okay, yeah.
So we have many side effects related to the inhibition of mTOR pathway as canonical pathway.
You are totally right. So as an enzymologist, I try to find deregulated enzymes. So it is why we begin with DPP4, which is a protease, and we try to find other deregulated agents. You're totally right, yeah. Well, yes, we try to avoid canonical as possible, canonical, yeah. Thank you.
The second question is about the possibility to target directly the longevity genes.
The longevity genes,
Yes.
it's a big question that is
Such
not
as
my
HER2
specialty.
and others.
Yes, you
isoforms.
have also longevity. So it's not just. It's also a matter of epigenetics and so on. So it's not only a matter of senescent cells. Senescence is only one of the how do we say that? In French, we say c'est la partie émergée de l'iceberg. So you have other elements so inside the cell, including epigenetics and so on, that can be so it is the next I think the next generation of compounds are epigenetic modulators. Ouais.
Thank you very much.
Thank you. There is another question in the room. So we thank very much Professor Al-Amri for her presentation. And I give the mic to Professor Tarzouti to present the second speaker.
Difficile de présenter Bouteina en quelques mots. Je vais essayer de faire une partie en français et je traduirai en anglais. Il m'est presque très difficile de présenter le cursus de Bouteina. Je dis toujours que Bouteina, c'est une mosaïque maroco-franco-canadienne. Bouteina, même sur le plan scientifique, c'est une vraie mosaïque. Une chimiste, une biochimiste, une pharmacologue, et puis une spécialiste des analyses de la chimie analytique, et puis de l'imagerie chimique. Bouteina, il a toujours été un pont entre le Maroc et le pays où il a séjourné. Et c'est grâce à elle que depuis 13 ans, et grâce aussi à Zoubida Charouf, qu'un master continue à tourner, celui des analyses des contrôles qualité des médicaments et substances à base de plantes naturelles. Ce master, il a formé des dizaines de masterants, des dizaines de doctorants. Il continue, c'est pour dire la longévité. Inutile de vous dire que Bouteina, il est lauréat de plusieurs prix et distinctions. Il est le réceptacle d'un financement de plusieurs projets. Et après son passage en France actuellement pour 10 années, il est à l'Université de Montréal pour une technologie de pointe, le MALDI, une technologie pour suivre l'évolution du métabolisme lors de plusieurs pathologies. C'est la chimiste qui est devenue biochimiste et qui devient aujourd'hui une physiopathologiste, chose qui me fait énormément plaisir. Merci Bouteina pour tout ce que tu nous as apporté. Et avec mon anglais, je vais essayer de dire quelques mots en anglais pour parler de Bouteina. Bouteina is specialist in biochemistry, bioanalysis, and analytical chemistry. Bouteina, from many years ago, decided to specialize in biomarker analysis using MALDI, a new revolutionary technology in the study of biomolecules. Bouteina developed many projects in French, in Morocco, and in Montreal. Many thanks, Bouteina, for coming.
Merci, cher professeur Tarzouti. Je suis vraiment gênée de la gentille présentation, mais merci beaucoup. C'est vraiment un honneur pour moi d'être ici, So I'm sorry, I will switch in English later, but I just want to thank really sincerely my colleagues and also the organizer, Hannah, Badr, Zubida. I call them by their first name because we are friends, we are family, so I don't use titles. And thank you also for welcoming me and also for the audience to be here. Students I met many times and they are very interested to listen to the topic. So yes, I moved to Canada 4 years ago, but I have been in Bordeaux for many years, more than half of my age. I won't say my age, but yeah, I was in Bordeaux for years for my study and then PhD and then my position. And after COVID, you know, everyone was questioning himself what to do, if to continue research or not, if it's enough what we are doing. And my first question, should I stay and continue as I am, or can I learn more? As Katya said yesterday, yes, I needed to learn more. So I just contacted other professors who are more experts than me and with more experience, and I asked if I can go as visiting scholar. So they welcomed me in US and Canada, and I prefer Canada because it was easier for my kids to speak in French. And yes, I'm there since 21, and I still belong to Bordeaux University. Now I got the title of associate professor in Montreal University too. And I'm really willing always to collaborate with Morocco because I was born in Morocco and it's my country and the colleagues are all my family too. So yeah, it's a pleasure to be here to share this part of my research, but also to see all of you. So thank you again. Now I'm going to start talking about this technology. Okay, so it's the MALDI imaging. And I choose to talk a little bit about the history before speaking about application. And I also added some application on natural products to be in the topic today. So for the introduction, I'm going to use my screen, sorry. So in the last 2 decades, mass spectrometry imaging gained a lot of interest, not only in biochemistry, in medical application, but recently also in natural products. Yesterday I was reading some articles. There are a lot of application in natural products too. And this advance in mass spectrometry imaging came with high resolution in mass spectrometry, but also a high resolution, spatial resolution, what we call spatial resolution, which is very interesting because we can go through subcellular dimension to detect biomarkers, to detect metabolites, and to be, you know, with accurate analysis and accurate data about the component of organs, organoids, and so on. So brief history of MSI. In I'm sorry, oh. Yeah, so in 1950, the birth of time of light, the TOF that everyone knows in mass spectrometry, and 1980 with Karas and Hellenkamp, the MALDI, the appearance of MALDI, and after with Spengler in Germany and Jimenez in 1994, direct analysis in single cells, which continue now, and finally Caprioli, who brings mass spectrometry imaging to the use of in the domain of biochemistry, proteins, biomarkers, and nowadays we are capable to construct molecular image from tissue samples. So just to give you an idea how it grows, the interest of this topic or this field of research, you can see the curve, it's still increasing and data are impressive. The research that is done is really very accurate, very nice. Every time I go and search for any molecule, like new molecule, I see, okay, it was done, or there is some approaches, which is really very satisfying because we see that we can also collaborate with colleagues all the world. And as you can see, also the field of interest, not only I cannot see clearly, or I don't know if you can see clearly, but there is biochemistry is the biggest area, chemistry, medicines, but also pharmacology and material science, physics. All the domains are covered and use this technology. The first country using this technology is United States, followed by China, Germany, and we can see France, Italy, Canada, and I hope very soon Morocco too. So the workflow, there is no or almost no sample preparation to use this technique, which is a good thing. It facilitates access to data easily and rapidly. So either you have a plant or animal, you will go through a very simple preparation after sacrificing the animal or harvesting the plant. We just freeze it, and then we go through cryosection. And after we apply a matrix, if we are using MALDI, I will speak briefly about it, or no matrix, no need of matrix, depending on the ionization source. Then we will use the mass spectrometry with a specific software that would help us to collect the image or to associate the mass spectra to the section image. So the MALDI, I think a lot of you who are in the domain of natural products or analytical chemistry, they know how it works. It's matrix-assisted laser desorption ionization. So this technique or source of ionization will use a matrix with a chemical product to help in enhancing the ionization yield from the sample. So to make the molecules ionized easily, and then they will be desorbed. We speak about desorption when it's solid. So desorbed and sent to the analyzer. So the matrix has a very important role, which is it will help to enhance the ionization process, but also it will reduce the intramolecular or intermolecular interaction in the sample, so it will help to desorb easily and have a great signal from the sample. So the matrix is very important in MALDI processing. So the choice of matrix will make it with a lot of care regarding the type of molecules we target to analyze, type of ionization mode, positive or negative. So there are many criteria to choose a matrix, and you may try many to catch the best. The other ionization source is the DAISY, which is desorption electrospray ionization. It doesn't need any matrix, okay? So here we have no matrix. You can use your sample directly without any matrix, but we will see the limit of this ionization source. The advantage, as I said, is no sample preparation. It's at atmospheric pressure, so there is no degradation of the molecules. The MALDI, we have two types. The one with atmospheric pressure and the other one who has under pressure. So it may degrade your compounds. And also the DAISY has the advantage that it may be automated, and you have, like the MALDI, you can obtain different mass fingerprint of your sample. Here are some examples of image we can obtain with the DAISY. So, sorry, yeah. So here, a very brief comparison between the MALDI and DAISY, those two sources of ionization, why we should use one or the other. The DAISY will work on ambient atmosphere, while MALDI will be under high vacuum. Also, about sensitivity, they are both great in sensitivity, but one thing that DAISY will cover only small molecules, while MALDI will cover a large range of mass. So this is very important to keep in mind. And as I said, no matrix, no sample preparation for DAISY. The last source of ionization I will speak about briefly is the SIMS. It's a very old source of ionization, but it was converted to be used in mass spec imaging. Why? Because it will give a higher mass accuracy because of this second ion production. So there is a beam of first primer ions, and then that will provoke or produce second ions from the samples. So the advantages of this, those secondary ions will have higher intensity, and more importantly, we can have three-dimensional spectra. So for tissue or organ analysis, it's very interesting, this ionization source. So as a conclusion on the ionization source for MSI, yes, SIMS or secondary ion mass spectrometry ionization will offer very high spatial resolution, very high mass resolution, but it's expensive, and still it's limited to small compounds. While MALDI, it's like the DAISY. The DAISY has the advantage is the cheapest. You can have it easily. But also it is concentrated on small molecules lipids. But if you want to cover higher range of molecules, better go with the MALDI. That's why you see that most of publications are based on MALDI technology. And I didn't put many details about the analyzer, but the analyzer is the part of instrument that comes just after the ionization source. And the ones that are used is either the time of flight, the Orbitrap, or FTICR. So the difference will be especially in what is the upper mass that we can cover, and also mass resolution and accuracy. Again, we can have one or the other of the analyzer, okay? But we will look also the one that will enable us to cover the largest number of molecules, especially in screening. We know that sometimes we want to see maximum of molecules, so better to go with the one that will offer maximum of information. So TOF, and that will have higher range of mass coverage. And FTCR is about high resolution in mass spectrometry. And we now have mass spectrometer that combine both. Okay, so they have a double analyzer that combine both advantages. So for my experience, I used to work with the SMALDI Orbitrap for mass spectrometry imaging. It's the instrument we had in Bordeaux before I moved to Montreal University. And the advantage of this SMALDI, that the source of ionization was in ambient atmosphere. So no pressure, no high vacuum, no degradation of samples, and the Orbitrap that offers high resolution in mass spectrometry. Okay, sorry. I need to go back. So yes, we can just underline the advantages of this instrument: high mass resolution, identification, validation of the identification of compounds, and also compatibility with the ambient analysis. Okay, and we can see here even about repeatability, accuracy. It's a very good compromise between high resolution, spatial resolution, mass resolution, spatial resolution, and also validation if we are interested in quantification. Okay. Now I will speak about the application. Among the project I worked on, I have chosen this one. It's about Alzheimer's disease, and it's a very recent work. It's an unpublished work. It's in collaboration with the University of Sherbrooke in Montreal, and I had a student with Professor Carl Fernandez. So briefly, this project was conducted with the help with the broker, so with using TeamStuff Flex. This instrument has a double analyzer. As I said, it's a trap and also a time of flight, so it combines those double advantages of high resolution and also covering high range of mass. And also it has double ionization source, electrospray ionization, and the MALDI, which was a big advantage. Additionally, we could do two-dimensional analysis because it can have what we call MALDI2, which means in 2 dimensions you can, for example, choose range first a round of analysis, small compounds, and the second one you can cover proteins, for example. So you have in the same image cumulated both range of mass. So let's go through the experience. So the experience was to investigate the therapeutic effect of ketogenic diet in a triple transgenic model of Alzheimer's disease. So I put here the diet we tested: control diet, carbohydrate-free high-fat diet, and medium-chain triglyceride diet. So the idea was to see if the diet affect or improve the profile, molecular profile of the brain in Alzheimer's disease. Okay, so here the parameters. So I worked in negative mode for the slide I will show you. So the range of mass that was covered, I targeted only phospholipids. The resolution, spatial resolution, was 20 micron. And for a sample preparation, the sample or section were dried in vacuum under vacuum for 30 minutes. And the matrix that was used, it's done. So it's the amino acid naphthalene, which has the advantage that it can ionize in both modes, positive and negative mode. So I could keep the sample after analyzing in negative mode, switch to the positive with the same matrix without using another sample, which is a good thing. So if you are interested, just keep this in mind. It's one of the rare matrix that allows working in both ionization mode. So here, example of results that were obtained, focusing on the hippocampus. We compared here, it was a project or small project before this one on diet that was to compare the inhibition of SCD and to see if we can distinguish this comparatively to non-inhibition of this enzyme. And we could separate the groups of different animals, but unfortunately among 398 ions, only 11 could be acceptable for interpretation because of repeatability. So we need to validate. So we have the criteria to have relative standard deviation lower than 15%. That's why we decide for the project that concerns the diet to cover the whole section of the brain, to get more data for this comparison, not to focus on only small region from the brain. Sorry, so we decided to make the whole section. So this is an example of lipids that were detected and their distribution in the brain. Now I will show you some examples from lipids that were detected and that are related to Alzheimer's disease in different cases. So here, example for monounsaturated fatty acid, trans-2 oleic acid. And we can see the comparison between the wild type 3-XTG in the 3 diets. Okay, the control, the ketogenic in the end, in the last line, and the medium fatty acid here in the middle. So the idea was to compare the effect of the diet and see if there is any difference, or we can recover the lipid profile like the white type. So I'm going to show the other lipids. So here, example of sphingomyelin. And the last one will be ceramide. So as you know, ceramides are involved in, or well known to interact with the Alzheimer's. So they are K mediator of neural apoptosis that is induced by oxidative stress. So here we have the galbeta ceramide, and we can see also how it changes under the diet, the control, the medium fat, and the ketogenic. Taking molecules one by one, section one by one, cannot give us a good idea about what's happening and changes. So the best was to combine all the analysis and make a principal component analysis, discriminative component analysis, and see what's happening in the whole image, whole picture. So we compare the white type with the 3-XTG under controlled diet, and we see if there is any resemblance, differences. So we could distinguish clearly the two, which is normal. A brain that has this disease should not be or looking like the one that is normal. Okay, so we can distinguish in control diet, which was expected. And here in the medium chain triglyceride, again, the effect of this diet didn't bring the Alzheimer's disease to a normal profile. So we can see the two groups well distinguished again. Sorry. And the last one is the ketogenic diet. Here we see overlapping of the profile, both profile. So it's less evident to see distinguishing between 3-XTG and white type. So just to summarize, this conclusion made us think that ketogenic diet can have an effect or effective role in improving Alzheimer's condition. So here the multi-analysis has generated multiple spectra in negative and positive mode. We had to select based on literature and also based on previous experience a list of lipids and focalizing this lipids. Also, we have used annotation using software or database like Metaspace or Lipid Maps, but you cannot use those databases if you don't have high resolution in mass spectrometry. If you're, your analysis is done with low resolution mass spectrometry. When you load your data, you cannot predict or annotate any compound. So the idea from this work was not only to detect the effect of, yes, of course, it's the main goal, the effect of the diet, but also to see the differentiation and what are the molecules that vary, and then continue the work to understand how this diet can affect the brain lipid profile. For natural product application, it was just the conclusion about Alzheimer's, sorry. So for natural product application, it's not my work. I just look for examples from literature. I worked on natural products. We started with Subida with the argan seeds, and I also worked on tomatoes, but I didn't show this. I wanted more recent results on natural products. I saw in literature examples like here, the mass spectrometry imaging was used to visualize the distribution of flavonoid in lychee. So we can see here the optimal image of lychee seed, and I'm going to show you what they got from mass spec imaging and how mass spec imaging could help in this, sorry, I went, okay. So here we can see the distribution of flavonoid. You don't need to be an expert to understand the result of those images. We can see different spatial distribution, which is sometimes very important to target which part we should extract. If we are interested before any extraction, just keep the whole sample and you can see where is the compound you are interested to. So this is a good example of how mass spectrometry imaging can be used in the field of natural product. So here it was used, yes, for detection and imaging of flavonoid, and overall there were 15 flavonoid that were successfully imaged, and with a specific location, which is an information that was important for improving the efficacy, for example, of extraction and the use of this fruit. The other example I found in literature, it's using mass spectrometry on spatio-temporal distribution of alkaloid this time, okay? And the plant was Gelsemium elegans, so they use mass spectrometry imaging for that. I think 21 alkaloid were detected and localized and differentiated between different parts of the plant, seeds, roots, and leaves. Sorry. Yeah, so we can see different part and the distribution of different alkaloids. Again, it's very interesting not to extract the whole, you know, yesterday I heard and some colleagues were speaking about toxicity of the extract because there are many compounds. So if you have this idea of the localization of specific compound, you can target it and maybe improve the efficacy of your extraction and your application later. The last one, sorry, I need my notes because it's not my work, I'm sorry. But they are good examples for application. So here, Bambix batricicatus, it's a Chinese medicine and it has a long history in clinical application in China. It is used mainly for the treatment of liver wind and phlegm and convulsion. So they use this because there are differences, to confirm, to identify and localize proteins. I took those three examples, alkaloid, flavonoids, and proteins, to show you how mass spectrometry or multi-imaging can cover different type of molecules and the interest of this technique. So here there is a significant impact of the holistic chemical transformation of this product, natural products. So we will see in the next slide here the difference or different proteins, also the comparison between before frying and fried product, okay? So this is important as it is used as a medicine to know how it will impact the content and the richness of this product, this natural products that is used as a medicine. So it was all about examples I wanted to show you for the mass spectrometry imaging use. And yeah, we conclude about the plant spatial omics, because that is the role of mass spec imaging. So this is a very good field of research, and I think that all of you who are working on natural product, you should collaborate and associate this technology to your research, because it will be of a good help of your research. And it's also used not only for detection of metabolites or markers, it will help also in plant science, plant physiology, pathology, interaction, or resistance to biotic. So that's it. It was the message for you for this technology. I'm not trying to sell this technology, but yes, I'm just sharing the interest and application that you could have for this. Oh, sorry. So what is the future of this technology, and how can we use it and evolve this technology more? As everyone speaks, or almost everyone, AI is here, and AI will also help us to take more advantage from this technology. The other thing is the multimodal approach. So you know that in the field of chemistry or botanic or biochemistry, we cannot rely on only one technology. You have to associate with many technologies to have accurate result, accurate information to be sure. And then once you develop a drug or you have an idea about the process or evolution of a disease, you have confirmation from different technologies. So the idea is to use MSI with other technology of imaging, like histological technology, but also analysis. And with AI, we can transform and combine all those results to have functional information and structural information too. So this is the idea, and this is the evolution of this technology. Yeah, so this is the last thing, or where this technology is going, is the multimodal approach. Like any analytical chemistry method, it cannot work alone. I think that's all. I finished. I didn't remember how many slides I got. So I would like to thank all my colleagues that helps in this project. Brooker, they helped me because I didn't get the instrument yet, so I could go to Boston and work on the instrument. And also from Montreal University, from Sherbrooke University, Carl Fernandez and his team, and Paul and Nora. We worked on the diet effect on Alzheimer's disease. Pierre Choron, we have, he was my host, in fact, in Montreal. And all the organizers, all the colleagues, and you for your attention, of course. Yeah, that's it. Thank you so much. I don't know if I was.
Many thanks, Boutaina, for this polydisciplinary study. Many questions for Boutaina. You can answer him in Arabic, in French, in English, in Quebecois language. In Berber. You have 5 choices for answering Boutaina.
Yeah, many thanks for this fascinating lecture. We had yesterday the lecture of Professor Wolfender showing how we analyze plants, very complex, made separation, everything, then these networks. But actually, for example, we have quite a large number of plant samples. We could just, without any preparation, use your method.
Yeah.
Is it feasible?
Yeah, it's feasible. You know, I think it's like, I remember I was student, mass spectrometry and chemistry generally was scary. People just, when they don't know technology, when they don't know a field, they get scared. And multi-imaging is like that. People, they think it's very complicated. I want to say, no, it's not complicated. It's really accessible and feasible. But you need to have money because it's expensive. That's why maybe it's not that, common to have in every lab a mass spec imaging. Yeah.
Thank you very much.
You're welcome.
Please, another question here.
Yeah, thank you, Buddha. Really interesting, and not being an expert in multi-turf and MS-based technologies at all, my question comes, very much from how can we actually make sure that the data which are generated in this context are reliable. And I'm also coming back to my experience here as an editor, and where we have chemical profiles submitted of plants where sildenafil is included. Now, to the best of my knowledge, no plant produces sildenafil. And I can name all sorts of other rubbish. Obviously, it's a question of the databases you use. So there are, for me, two strategic questions. One is training. Most of these come from pharmacology groups, and they pass it on to someone who knows what to do, and then they get the data back and they don't think. So that's the training part. The other one is following up on what Olivier said to some degree, or what you responded to also. How can we make this actually available globally to research groups which may not have the funds which you have in industry? So I think both are needed to make science meaningful and reproducible.
Yeah.
Thank you.
I totally agree. First question about reliability and accuracy of results. Myself, I don't go to molecules I don't know, really, because I am afraid to have, even with high resolution, you can have many compounds that look like that they have the same molecular weight. So first, high resolution will reduce this confusion and mistakes. The second thing, as you said, is the knowledge. You have to be critical about your results. Is it logical to have these compounds in this organ? For example, if you are working with animal organs, you have to filter first. I want just animals. I want this type of molecules. I am in this, and now database or what I cited in the beginning, lipid maps and metaspace. You can select which type of samples you are dealing with. I mean, it's you can first have some filters like that, and also knowledge collaboration. Don't work alone. It's because if you are you master the instrument, you may not master the natural products, compounds, or also physiology of animal organs. So you need to collaborate. I encourage students and even my colleagues to collaborate. There is no shame to ask even a colleague who's more knowledgeable, okay, what do you think? I think I found something interesting. What do you think? Before going to publication, as you said, or the colleagues said, publication is the last thing we should think about. First, we have to be sure about what we found to ensure I really don't care about the number of articles I can produce, but I care about the quality of the science I can produce and the quality of the science I can teach my students. This is the most important. Yeah, training. Yeah, exactly. You're right. And also about having access to the instrument. I saw in Canada, I was living years in France, and I moved to Canada. They encourage collaboration. Instead, they don't go and found one lab. They said, okay, gather together. You are all working, or at least you need this instrument. So you have to have this common project, and the instrument will be commonly used. This is the best way to have access to this instrument. We cannot hope that the price will reduce, because there is huge technology behind, many components, I mean, it's complex. So there is no way to have reduced price from the constructors, but we can gather together and have, instead of everyone having his instrument, having one instrument for, I don't know, one region or different labs, international collaboration too. Yeah. My colleague Ganesh Halat, he will say it also. We are collaborating. He is in US. I was in France. He was sending heart samples. We were working on cardiovascular disease, and it was like that. He's very expert in his domain. And we met in a conference years ago, and then we started collaborating. It's like that it works. We cannot all of us, possess all the instruments. I don't have NMR, I don't have many instruments, some of you have, but I collaborate. That's it. Thank you.
Another question? Ilham?
Thank you, Butaina, for your interesting presentation. I just look the slide when you talk about natural compounds, quercetin, retin. Yeah, is Maldi can distinguish between quercetin, like quercetin and quercetin triglycoside? And the second question is about the intensity of luminosity. Is it dependent of the concentration of the natural compound?
Yeah, sure. I will answer the first question. MALDI is just the source of ionization, okay? It's the one that comes and make your compounds becoming charged instead of neutral, okay? Just to help and just to be precise about this technical aspect. So it's the analyzer after the MALDI that will give you a certain accuracy about detection. That's what I was saying, high resolution mass spectrometry. If you are using only the time of flight, be sure you won't distinguish them, okay? Then you need to have, for example, a QTRAP or FT-ICR, which has a higher resolution in mass spectrometry, and you can be sure, like in 0.1 ppm, the exact mass, and you can recognize your compound. Then you have to go through MS2 to ensure, and maybe NMR, the structure of your compounds. This is just the beginning, but if you start, in the right way, you will finish with the right results. The second question about intensity, there are many things, not only the concentration itself, in the organ or in the product that will affect the signal, but also how you treat your sample. Most of the publication will be on small compounds on lipids. For example, in animal organs, if you are interested in peptides and proteins, you have, I said there is no sample preparation. I was lying, partially, not really, not lying, but for example, if you are interested in protein or peptide, you need to wash your section. It's not a huge preparation to remove all lipids because they are more abundant. So it's a question of competition between molecules, which one will be the most ionized, and then it will give the signal. It's not only the concentration, but all the process will help you to enhance the choice of the matrix and also how you prepare your sample to get the best signal.
Thank you.
You're welcome.
Thank you very much, dear Butaina, for this interesting presentation and for eclaircissement. Thank you very much. We have to move to last presentation. It will be from so far. The speaker couldn't be with us physically. The presentation will be by video conference. So I switch to Professor Ganesh Halad. Please give connection to Professor Galad, please. S'il vous plaît. So I told that the last presentation will be from so far from University of South Florida, Heart Institute, from Department of Internal Medicine. The research objective of this work is to determine on how unresolved chronic inflammation and immune responsive metabolic dysregulation contributes to ischemic and non-ischemic heart failure. Professor Halad's lab research focuses on studying heart failure etiology with an integrative approach focusing on splendid leukocyte and heart. On also measurement of inflammatory mediators that impair cardiac repair and resolving lipids mediators that facilitated cardiac repair after heart attack. The role of a resolution receptor in inflammation resolution process in heart failure, and at least translate our the findings for use in human therapy. And the important thing of this, that the study considers risk factors such as obesity, diabetes, aging, and co-medication like oncologic drugs. So it's okay. Professor Ganesh, you are with us? Professor Halad? Professor Halad, we don't hear you if you are with us. We have to wait few seconds. He will connect another time. Yes, in few seconds. Les aléas de la technologie. I just remind that the presentation will be on, as is it presented behind of us. It will be on regulatory affairs in drugs, dietary supplements, and medical devices. So we are waiting for Professor Halad to be connecting.
في صوت مش طبيعي.
Nous profitons de ce petit moment pour inviter Professeur Shahrazad et Professeur Boutaina to join us. Please, we have something for you, Boutaina et Shahrazad. فين بوتسينا؟ Oui. Boutseina, join us please. En attendant, professeur Charouf a une annonce à nous faire.
Bonjour tout le monde, j'ai une annonce pour la table ronde de cet après-midi. Donc j'invite tout le monde, les chercheurs, les étudiants, parce que vous êtes des utilisateurs des ressources biologiques. Vous envoyez votre matériel dans d'autres laboratoires et maintenant la législation va changer. Et donc je vous invite à venir à la table ronde pour savoir ce que c'est que le protocole de Nagoya. Et au Maroc, il va bientôt, il est en train d'être implémenté, il va bientôt entrer en vigueur. Le Maroc a déjà signé le protocole de Nagoya en 2011, il l'a ratifié en 2022 et le ministère de la Transition énergétique et développement durable est en train de le mettre en œuvre. Donc je pense que vous avez tous intérêt à venir à la table ronde parce que ça va changer. Et vous avez entendu hier, non, le premier jour, c'est ça, hier, que maintenant, même pour les publications, on va vous demander si vous respectez le protocole de Nagoya. Donc, vous ne pouvez plus publier non plus. Merci.
Merci beaucoup, professeur Charouf, pour cette annonce. Alors, on profite de ce moment pour présenter un petit geste. Professeur Lamri, pour avoir accepté d'être parmi nous aujourd'hui, de nous avoir honorés par sa présence et pour nous avoir présenté ses dernières avancées dans son domaine. Et Boutseina nous rejoint. Join us, please. We have a small thing for you. To thank in you. شي حد عندكم solutionné? Non, c'est
On va se connecter maintenant. Deux autres belles. Il va passer la première. OK?
So,
on va le programmer la première session après l'autre. Deux informations. D'abord, nous, صلاة الجمعة وغندخلوا لا سيسيون غادي يكون ان شاء الله
So we have to wait few moments. They are trying a last time to join Professor Hallard. If we don't success, we will change the program. I will announce you what we will do. Butaina is joining Professor Hallard. So we changed the program. The presentation of Professor Harar will be done in the afternoon at 3 p.m. We have a break, but the lunch will be at 2 p.m. 30 because of prior of we have to wait from priors. Today is Friday, a special day for Muslims, so we have to wait, but we are in break now until 2:30 to have lunch, and we have to return here at 3 p.m. inshallah.
Hello? Hello? Hello?
Hi, Ganesh. We can hear you. So I will give the micro to my colleague. She introduced you already. You can say a word about your work and explain.
Thank you, Ganesh, to be with
I just
and join us.
Yeah.
So we give you. You can present. All are here.
Sure.
Sorry.
I have a challenges with sharing with my slide.
Sorry.
Yeah, can you hear me?
Yes.
Can you hear me?
Please, can you tell us how many times you have to?
I have a check.
How many times you have to present, please?
I will take only 2-3. I will take only less than 3 minutes because I have challenges in sharing the slide. I just want to share my apology because of the very slow connection. So I'll just share the theme and I will stop because I have challenges when I share the slide, everything shuts off. So that's why I just use my audio and share that what I'm doing and stop. Is that okay?
Okay. No, thank you. Yes. Okay. Take your time to present. Yes.
Yes. Yeah. Thank you. Yeah. Thank you. Thank you all for the organizing committee for invitation. I'm very pleased. But unfortunately, because of very unstable connection, whenever I try to put my slides, everything research team in a very brief. I work with Tino and many other colleagues there, and I'm very pleased to associate and collaborate with all the team members over there. So what I do as a research, everything from heart attack to heart failure. I know in the Morocco, argan oil is very well known. Same thing. My field of research is the omega-3 fatty acids or fish oil. When the fish oil or any oil what we take in the body, it is used by enzymes, that is the second step, and the third step, it forms the molecules and it activates the receptors. So these four components act as the wheel of the car, and if one component is disrupted, that leads to heart attack or heart failure or any type of chronic diseases. And the theme of this conference, the sustainability, whether it's argan oil, or whether it's olive oil, or whether it's omega-3 fatty acids or omega-6 fatty acids, how they get metabolized in the body and forms certain molecules that use the calibration of your immune cells. Because if your immune cells is perfectly fine-tuned and happy, it can prevent all types of diseases. But if your immune system failed, or if there is some challenges or miscalibration to immune cells, then it leads to disease. So that's the whole entire theme of my research in context of especially the omega-3 fatty acids. Once it goes in the body, it forms many molecules. These molecules called as a specialized pore-resolving mediators, and it activates receptors. So that's the whole theme, and that's applicable for if this disruption leads to chronic inflammation. But this is very responsive to your diet, sleep, and exercise. That's my whole presentation was there, but because of the technical difficulty, I have to back off, and I will let you go. Thank you very much and appreciate, and I sincerely apologize for this inconvenience to all of you, and appreciate your invitation and patience. Thank you.
Thank you very much, Professor, for your presentation and for your be available to be with us today. And we apologize for the technical thing that's above a few minutes ago. We hope to have with us nextly.
Sure, definitely. I will plan to come in person, which is the best possible way.
Yes, yes.
Yeah.
Thank you very much. And we see you nextly. Thank you very much, Professor.
Thank you. Take care. All the best.
Goodbye.
Bye.
Alors, je rappelle que le déjeuner sera servi à 14h30 après le retour de la prière du vendredi pour ceux qui sont partis. Donc, dans 30 minutes, on doit être à la terrasse, d'accord, pour prendre notre temps quickly to have a lunch et retourner ici vers 15h pour reprendre les travaux de notre congrès. Merci.
Thank you. Thank you.